Hello, good morning everyone. I would like to request all the dignitaries to please come up on the stage. Okay. So I would like to request Shri Brajesh Kumar ji, Shri Shankdeep Das ji, Shri Ajit Shah ji, and Shri Sudep Gupta ji to come over the stage, please. Okay. I would like to request Dr. Mahendra Sharma sir to please come up on the stage. Good morning, ladies and gentlemen, respected dignitaries, esteemed guests, my leaders, researchers, and innovators. It gives me immense pleasure to welcome you all to the Additive Manufacturing Conclave 2025, organized by the National Additive Manufacturing Center West at Ganpat University and sponsored by Stratasys Design Tech, STPL, 3D Selfie, Ace Micromatic, Geo 3D, Hexagon, Kodiar Group, and Tirusai Mobility. This conclave is envisioned as a strategic platform to accelerate India's additive manufacturing ecosystem, bringing together policymakers, industries, academia, startups, and innovators under one roof. Throughout the day, we will be witnessing keynote addresses, thought-provoking panel discussions, live technology showcases, and meaningful networking opportunities, all centered around the theme, accelerate, adapt, automate, and align and achieve. Together, let's explore how additive manufacturing is transforming industry such as automotive, healthcare, aviation, and electronics, while also addressing national priorities like skilling, sustainability, and innovation. We feel proud to say that National Additive Manufacturing Center West at Ganpat University is a premier institute supported by MITI, Government of India. It serves as a national hub for skill development and training, indigenous technology development, research prototyping, consultancy, startup support, and innovation in additive manufacturing. Following our GUNI tradition, we would like to start the event with the statement of gratitude. Ganpat University is deeply grateful to its founders, donors, trustees, donors of land, and the Constitution of India for giving the society and the country a great institution based on the philanthropic mission of Vidya Samaj Utkarsh, that is social upliftment through education. The GUNI family further acknowledges the contribution of all its stakeholders, including the Government of India, the Government of Gujarat, all past and present members of the Board of Governors, the Academic Council, the Finance Committee, various bodies of Ganpat University, all its past and present office bearers, partners, staff members, parents, and students. We sincerely thank each of individual for their gracious contribution for helping us reach to the forefront of social, cultural, and educational initiatives and endeavor for the nation. Without further delay, let us commence the inaugural session with the auspicious Diya Lightning Ceremony. To mark the beginning of this inspiring day, may I request our distinguished dignitaries to kindly step forward to the ceremonial lamp lighting, symbolizing knowledge, progress, and enlightenment. Let us welcome them with a huge round of applause. Thank you so much, sir. To extend a warm welcome to this august gathering, I now invite Dr. Mahendra Sharma, Honorable Group Pro-Chancellor, Ganpat University, for the welcome address. Please, sir.
Thank you, Professor Trivima Sharma. Good morning, everyone. It is a great day. Ganpat University is hosting the National Additive Manufacturing Conclave 2025, and we are really blessed that we are in the august presence of several illuminaries from the state as well as abroad, and we are really fortunate that the stalwarts from various associations are also joining us on the dais as well as online today to not only witness the exchange of thoughts during this conclave, but to guide and mentor this national mission. We are really fortunate that we have with us the Honorable Patron-in-Chief and President of the University, our beloved Dada, Shri Ganpat Bhai Patil. Dada is joining online from California. Thank you, sir, for being there. We are really delighted that Shri M. Nagarajan ji, Vice Chairman and Managing Director of Gujarat State Road Corporation of Gujarat, is joining online in few minutes. He was actually supposed to be here, but because of a important meeting given Prime Minister's visit to Gujarat, he is not able to travel. We are equally delighted that we have the blessing of Shri B.H. Talati, Director Technical Education, Government of Gujarat. He would be joining online soon. and he is engaged in the same event. But the best thing that he did was he circulated the entire conclave to all the government institutions in the state of Gujarat, particularly engineering, polytechnic and ITI institutions, and requested all the heads of the institution to join online as well as physically. So we are really thankful to both Nagarajan sir and to Talati sir for continued support. We have in our August gathering Dr. Shankhadeep Das. He is a scientist with Ministry of Electronics. Das Sahab has been the man who was instrumental in ensuring that Ganpat University got the National Additive Manufacturing Center for the West. Thank you, Das sir. And you have been supporting us throughout, guiding us like we are one of your own. And you have been very instrumental in helping us choose the right machines, the right approaches, and the industries that we should work with. Thank you, sir, for being here physically and being guiding. We will learn a lot from your dictate today. We have with us on the dais Sudep Gupta, sir. He is the former Executive Director of Oil and Natural Gas Corporation of India, Mehsana Asset. And Gupta, sir, is also the chairman of our board for National Additive Manufacturing Center for the West. Thank you, Gupta, sir, for coming here and being with us today. We are equally delighted that we have with us in the August gathering Mr. Brijesh Kumar, the CEO of Instrumentation Automation Sector Skill Council of India, under whose purview additive manufacturing comes. Thank you, Brijesh Kumar sir, for coming here all the way from Delhi. And we know that this is very important for the skills mission of India also. And sir, with your guidance and blessing, we will take this torch further deep into industry and institutions. We are equally delighted that we have two stalwarts from industry with us. Shri Ajit Shah Sahab, he is president of Sanand Industries Association, and Shah Sahab is driving the Gujarat state's what we say is the manufacturing engine in automobiles and electronics, because Sanand is the hub. Thank you, Shah Sahab, for coming here, and he has a special purpose why he is here. So his trust on Ganpat University and our methods has been so deep that recently Government of Gujarat, it was all his effort ever since he took over as the president. He was trying very hard. Probably, sir, Sanand GIDC માં 550 કરતા વધારે કંપનીઓ મેમ્બર છે. More than 558 companies from big names you can think are the members of this association. And he tried hard to put an industrial training institution there in Sanand. And after they were given this ITI, Shah Sahab reached out to Ganpat University. He always believed that we have that deliverability and the abilities to participating in skilling and upskilling and tailor making it for the needs of the industry there. So today we will be seeing an MOU signed under his blessings and patronage with Sanand Industries Association, where Ganpat University would become a vehicle of enabling that ITI. Thank you, sir, for believing in us and trusting us. It means a lot. We are equally delighted that another industry stalwart is among us, Shri Jitendra Panchalji. Sir is director of Ahmedabad Manufacturing Association. Now, when we say Ahmedabad Manufacturing Association, sir, 10,000 કરતા વધારે સભ્યો છે આપના ત્યાં. એટલે સાહેબ એમના ડાયરેક્ટર છે, અને જ્યારે પણ મને મળવાનું થાય છે, every time he meets me, he says, I will bring 100 of them to the campus and I will host them on your campus, because these manufacturers have a very strong need of skilling, upskilling and researching. And institutions like Ganpat University can be a very fertile ground where we can educate them. And with small, medium, micro enterprises coming to the campus, participating with the knowledge ecosystem, it is always a win-win proposition for both the industries as well as for the university and the institution. And it opens up a lot of ideas for startups. Thank you, sir, for coming and joining us today. We have a very strong team of committed people here with us. Our Senior Pro Vice Chancellor, Dr. R.K. Patil, our Pro Vice Chancellor, Dr. Satyen Parikh, our Executive Registrar, Dr. Girish Patel, the team behind this entire organizing, our Executive Dean of Engineering and Technology, Dr. Kiran Amin, for Diploma Engineering, Dr. Kalpesh Patel, and the chairperson, the man who is driving this National Additive Manufacturing Center as a Chief Scientific Officer, Dr. Achyut Trivedi. Online you can see our Pro Vice Chancellor, Dr. Saurabh Dave. He is sitting in Goa but playing a vital role here in ensuring that the startup ecosystem benefits out of this conclave. So we have a very strong presence of people. Our Director Placements and Executive Education, Dr. Kishore Barad, our Director Research, Dr. Ajay Gupta, our PRO, Vikesh Bhatt, and all the committed members, faculty members, organizing team, who have all put together their effort to see this day. And it's very important because while we are talking about National Additive Mission, our government started talking about it almost 5 years before, and this is the day, August 23, 2022, when our National Additive Manufacturing Center West was established, and we are completing 3 years of our establishment. So we chose August 23rd as a day so that we can reflect on what we have done, how far we have come, and are we becoming an enabler on the mission and the objective of National Additive Mission of Government of India. So while we are here, we are talking about it. Globally, the situations are also equally challenging. Today, probably Prime Minister, when he gave us the mission of Atmanirbhar Bharat, Make in India, it can never have been a better time to talk about it, because globally we are facing challenges from friends and unknown countries who are now not favoring us anymore. So our economy to remain self-reliant, to be globally competitive, and our vision of becoming a developed country by 2047 and to become the third largest economy of the world, probably such kind of deliberations and where technology can be brought for the evolution of small, micro, medium enterprises has to be deliberated, and additive manufacturing is one such technology. Let me start by invoking the word of Chuck Hull, the inventor of stereolithography and the father of 3D printing, who said, "The beauty of 3D printing is that it allows us to make things that we could not make any other way." This is something which is a very crucial statement, and it resonates very deeply as we witness additive manufacturing transcending traditional boundaries, enabling the creation of complex geometrics, lightweight structures, and customized solutions that were deemed impossible. Yet, in critically evaluating from innovation to the detailed agenda of today's conclave, you will see that we have to look at the promise and the imperatives of this technology. And it will also bring to you that there are certain inherent challenges when we are talking about additive manufacturing. There is a need for widespread adoption. There is a need to fill the skills gap. And we need to create an ecosystem for integration, particularly for small and medium enterprises that form the backbone of Indian economy. And there is a need for researchers to push the frontiers of material science, and students to be educated to be part and parcel of this revolution. And it's not without reason that I am talking about why we are as a country lacking behind the global giants like US and China as far as adoption of 3D technology is concerned. If I look at the statistics, you will find that National Additive Mission has set a goal for 5% global market share, which is almost $1 billion to the GDP by 2025. This was the year we were talking about it. And if you look at what is happening in the world around, the US holds the largest share with system sales revenue far exceeding others, followed by China, which is rapidly scaling in metals and electronics, Germany, which is pioneering in automotive and precision engineering, and Japan, which is leading in healthcare application. In contrast, India's additive manufacturing market, valued at currently $0.7 billion, is smaller, represents about 3% of the global pie, but growing faster at a rate of 21 to 22% CAGR and potentially reaching $2 to $3 billion by 2030. It's a mission. And that's why about all these developments which are happening, through the data, the center currently, the National Additive Manufacturing Center, with the money given from the grants given by Ministry of Electronics, the support of Government of Gujarat, we are able to have an ecosystem of machines like F170, F370, F770, FDM, triple F printers for industrial jigs, fixtures and aerospace parts. We have STPL INSL 600 for large format high resolution SLA printing, Markboard Jet 18 and Object Dental Prime for DLP applications in dental and medical prototyping, and the J5 MediJet for biocompatible medical devices. Complementing these 3D scanners from Hexagon, CAD tools like SolidWorks and ANSYS, mechanical testing equipment such as universal testing machines, thermogeometric analyzers, differential scanning cardiolometers, along with in-house polymer filament extruders and post-processing units like CNC hybrid finishing system. Now this whole ecosystem that in the phase 1 which we have developed is significant enough to enable the industries spread in our 200-kilometer area. But we want this particular center to become an hub and spoke model, wherein the center, the main facilities are here, but the training, education and educating the industries and doing a small consultancy project can be spread across the state of Gujarat, and we can, with the permission of the government, spread it to other states also. So we are actively thinking about how we can make the best use of enabling this, using this center and enabling the Gujarat's economy, enabling the small, medium, micro enterprises, and help them test their products, develop the prototypes, play with the material, try to work on its durability, on its cost, and make it competitive in the market. So this is where there is also a need for research institutions, universities to come in and take up active research in material science and create newer opportunities for our small, micro, medium enterprises owners, as well as propel the startups to adopt this opportunity. So the day today is organized very impactfully. After the inaugural, we have expert sessions, we have panel discussions, and we also have a very in-depth showcasing of the existing center. So all the industry participants who have come, they will be visiting the center. They will have a first-hand feel of the prototypes that have been developed through that center and what are the opportunities. And we take this particular opportunity to invite the industries to give us the problem statements, the challenges, the various opportunities that they are facing, but they are not able to solve, and can our center become a significant player in helping them develop a prototype which is very competitive, help them address the cost competitive issue, the durability issue, the product's usability issue. We can do lot of significant things here, and we are looking forward to those kinds of problem statements and handholding from the industry. And while all the dignitaries are there, I know they have their own part of experience to relate and share, and while we will be talking about it, it would be great learning for everybody. And we are also, Government of Gujarat this year in October 9th and 10th has chosen for the regional round of Vibrant Gujarat Summit Ganpat University as the host. So we will be having the regional round of Vibrant Gujarat Summit hosted at Ganpat University, and probably this technology has to be showcased very extensively during the summit so that all the small and medium large owners can learn about it and how they can adopt it. And we have a long mile to go in fulfilling the objects of its establishment. So I welcome you all to this important conclave, and I understand and I know that we will have very impactful discussions and outcomes as we have envisioned. Thank you very much.
Thank you very much, sir. Moving ahead with the floral welcome, I would like to request Dr. Mahendra Sharma, sir, to welcome Shri Brajesh Kumar with a GUNI stool, a statement of gratitude, and a Wali art painting made by our architectural students. Please, sir. Please give a big round of applause. I would request R.K. Patil, sir, to welcome Dr. Sankhadip Das with a GUNI stool, statement of gratitude, and a Wali art painting made by our architecture students. Please, sir. We would also like to welcome Shri Ajit Shah, sir. Thank you, sir. We would also like to welcome Shri Sudep Gupta, sir. We would also like to welcome Sri Jitendra Panchal, sir. We would also like to welcome Shankar Tekwani, sir. Thank you. Thank you very much, sir. We would also like to welcome our chief guest, Sri Nagarajan, sir, and he has joined online with us. Sir has served as the district magistrate of Mehsana and is also known as a goverpreneur at heart, which is how a central banker became a bureaucrat. Sir has a working experience of 23 years in various government departments, including Indian Railways, the Indian Audit and Accounts Department, and the Reserve Bank of India, and in the Indian Administrative Services. Sir has served as the collector in various districts of Gujarat. I would request Sir to please address the gathering on this auspicious day. Please, Sir. Hello.
Hear me?
Yes,
Yeah.
we can hear you.
Yes, sir, we can hear you.
Okay. So other members of the trustee board, the Vice Chancellor, Shri Mahendra Sharma ji, Dr. Saurabh Dave, all eminent faculties of Ganpat University, and my dear participants from the academia, industry, startups, innovators, and all enthusiasts who are interested in manufacturing excellence through additive process. I am very happy to be back again in an occasion of Ganpat University, especially when Dada is also present here. We always talk about how Mehsana is contributing to the national development by building capabilities and skills in deep tech sector. In deep tech, we are always carried away by AI or even some other new technologies, drones and other things. However, one of the core pillars of Industry 4.0 is the additive manufacturing. Generally, we all people, laymen like me also understand it as 3D printing, but it has a lot of applications, especially in the industrial sector, from the nanoscale and the semiconductor to the bigger scale in civil engineering to even industrial manufacturing. So I'm really happy that this conference is organized at the national level to discuss about the advancements, challenges and opportunities of additive manufacturing. Fundamentally, the additive manufacturing is bringing a paradigm shift in approach to building things or making things, and this is going to be the future. Countries like China and USA are far ahead of us in this, and we need to cover up this gap by building skills. When I mean skills, it is not just lab level skills, but field level skills. So this National Center of Excellence started by the Ganpat University, of course, with this active support of state government of Gujarat and also the government of India. This is an important infrastructure in the entire nation. And this conference is providing a platform for people who are not present in Ganpat University but associated with additive manufacturing to come and learn here and collaborate. So that way, the investment that Government of India, the Government of Gujarat is making in the skilling and higher education sector is getting available for all the industry, startups and other researchers to use this for national benefit. I recall the day when Shri Rajiv Chandrasekhar, the then Minister of State for Skill Development, had visited Ganpat University. I was privileged to work in Mehsana as collector, and when we accompanied him for the visit, he was very much excited to see such advanced machinery that is being set up here in Ganpat University. And we need more this type of center of excellence. That was his words, because skilling is going to be the future. And this happened almost 2.5 years back. And today this culmination of conference is one more step, one more feather in the cap of Ganpat University towards building skills and excellence in the additive manufacturing process. Ganpat University already has set benchmarks in maritime, skilling and various other sectors, advanced technologies. But the additive manufacturing is core to Gujarat. Now MSMEs have to transform from the traditional methods of manufacturing to new methods. So availability of skilled manpower is a very important challenge. Whenever we talk to industry, especially from the government side they will always say, sir, we need talent. We are not getting talent. Even this challenge is now faced in the semiconductor industry. So what will come first, the chicken or the egg? Whether the industry will come first or talent will come first. This is a universal challenge for India, and we all should note the fact that by 2030, India will have the most productive population in the world. We will have the highest number of people, 90 crore people will be the most productive population and the biggest man force on earth that we should be able to harvest. Today we can see China is already in the downslide when in comparison to the population and also the aging nation. And we see advanced examples like Japan, which are facing very much difficulties even to run the basic economy because of lack of skilled manpower, and they don't have a young population. They don't have population. We have population, but we have to build the enough skill set. We still have the opportunity. We still have the choice. We still have the chance to support our youth. I request all the academia people here, professors, PhD researchers, to look at solving problems which are having industry relevance, which are having societal relevance. We normally choose a topic and then think for topics to do PhD within that. We should do the reverse process. Government of India and Government of Gujarat also want research that is really useful and translatable on the field. So let us start from the problem statements that are available in the industry, especially the MSME sector, especially in the sector which are very important for our country and also Gujarat. Let us start from there. Let us work with GIDCs. Let us work with industry associations to understand what is the challenge they are facing. What is that material? What is that machinery that they are importing from Western countries or China or other places? How we can replace it with local manufacturing. In Surat, I was working. When interacting with the textile sector, they always say, sir, we are importing so many spare parts. We are importing so many things, and when that spare part is not available or it is delayed because of some geopolitical reason, because of some logistics reason, then the entire production is stopped. We can produce many of these spare parts locally through additive manufacturing. I have to recall in this juncture the Common Engineering Facility Center created in Surat. This was done with Ministry of Heavy Industries support by Setu Foundation. They are providing the prototyping facilities. We have to combine such kind of a center of excellence in Gujarat and form a network for the additive manufacturing process with more prototyping facilities so that we are working closer to the industry. So I hope that Mehsana is having great eminence in the heavy engineering. We have Aman, Apollo Industries. We have so many other industries like Hitachi, Maruti Suzuki in our district itself. Now we have to see how we can be a bridge for supporting corporate innovation, corporate supported innovation through research, through center of excellence and skilling. For the industry people also, there should be free movement between the industry to academia, academia to industry, of course supported and facilitated by the government. So this conference, let us all try to think about these kind of topics, and I am sure that some actionable insights will be taken. And as Dada is always known for taking action immediately on the findings, I am sure he will put 3 or 4 implementable solutions on the ground immediately, which will be then day to day supported and pushed by Dr. Mahendra Sharma. I am very interested and eager to know what kind of new things will be implemented in the coming months and weeks in the additive manufacturing sector, and we can nationally set a great example for additive manufacturing. We already have set example for the automotive sector through the IACE and the other lab facilities, which is world class. Now additive manufacturing is the new sector where we can all work out. Lot of the researchers and academicians today might be thinking, what is in it for me? We have to explore it. We have to find the commonality of our existing skills with the new opportunities and create new alchemy of solutions which can be used for our country. I thank the organizers for inviting me, especially the Ganpat University team for having made these arrangements to bring so much of wonderful quality people into one room I really wanted to come physically. Because of Honorable Prime Minister's visit to Ahmedabad, I am not able to travel to Mehsana, but my heart lies in Mehsana, and I will always love to give back to Mehsana whenever it's possible, and especially through the academia for research excellence. Thank you so much for inviting here, and I wish this event all the best, and I congratulate all the participants for having taken the effort to come so far for learning this opportunity, and indeed this is a great opportunity for all of us and for India. Thank you very much. Wishing all the best to all of you.
Thank you so much, sir, for your valuable words. We would like to present our statement of gratitude to our chief guest today, Shri Nagarajan ji.
Thank you so much.
Thank you so much, sir. So, it is my privilege to welcome and invite Mr. Amir bin Ahmed, Vice Chairman of the Board of Directors at ASTM International. Sir is a distinguished global business leader with extensive experience in strategic management, innovation, and organizational development. He is also academically accomplished, having earned the advanced certificate.
Exchange of talents. Certainly, there is a huge shortage of talent globally. There is no doubt about that. And I think we've seen through the discussion, I believe even we'll discuss further today. But also, there's technological development that's happening at an enormous pace. Therefore, the final product must be certified and also verified so that scalability can become easier. If we succeed, AM will not be just produce parts. It will produce resilient supply chain, skilled talent pools, and global competitive industries. The ecosystem we build today will decide whether AM remains a niche technology or becomes a cornerstone of sustainable, trusted, and scalable manufacturing. Thank you. I extend my appreciation to Dr. Sharma, Dr. Ravi Mitra, and the entire organization team. It is through such platforms of collaboration that we move from vision to reality. Thank you.
Thank you very much, sir, for your insights. We would like to offer a statement of gratitude to Mr. Amir bin Ahmed.
Thank you.
Thank you, sir.
Thank you very much. Thank you. Thank you very much, everyone.
Yes. Now it is our privilege to hear from the visionary leader of this institution. I now request Patron-in-Chief and President of Ganpat University, Padma Shri Dr. Ganpat Bhai Patil, lovingly known as Dada, to share his words of wisdom with us. Please, Dada.
Good morning. Can you hear me?
Yes, sir. Good morning.
Okay, great. Respected dignitary, and I mean dignitaries. We have a great list of dignitaries, and I want to thank you, each and every one of you. Starting from Nagarajan Sahab, you have been inspiring collector for Mehsana and for us. I know you have left your heart and you have stolen some of our heart. We miss you, but I'm glad that we're working together. Dr. B.H. Talati Sahab, thank you for joining us today. Dr. Shankadas, Deep Das, thank you for joining us today. I still remember meeting you the first time in Bangalore, and you have been a great supporter of us. You were sold on us. Day we met you, I met you. Thank you, sir. Thank you for your support. Sudip Gupta ji, sir, thank you, and we love to work with you. We will work with you. We are about industry in the university and university in the industry. So we love the partnership with the industry. Nilesh Kumar, thank you for taking your time and joining us all the way from Delhi. Ajit Shah, I know you have a long list of industry, and we can spend days and days and days talking about it. I have spent most of my adult life in America, for my education as well as my work experience. And during my education, I worked with the industry. During my business, I work with the industry, and I know how important universities are to the industry. And this is why we have been so proactive in this area. Sir, we would love to work with you. Please keep guiding us, keep using us. We don't mind getting abused. Push us, demand from us, and we will deliver. We have a great team here, led by Dr. Sharma. Thank you, Sharma Saab. Skilling, upskilling, reskilling. We have done it for the rest of the world for a long, long time. This is about time that we do it for home. And I think we have a right Prime Minister pushing for it. He understands every minute about any technology, anything at all. And what he does not understand, he quickly learns. He is a quick learner. And he's a quick supporter of the right technology. I know him from close up. I know I bought a first machine 8 years ago. So, Sharma Sahib, we started this initiative 8 years ago. 3D printing was relatively new technology in America. But I was supplying my power supplies to a company called Stratasys, and we bought our first machine from them. And I'm glad that we were a little bit ahead of the time, but it is better to be ahead of the curve than behind curve. And that's what we are doing today. Industry leaders, scholars, innovators, and my dear student, thank you for joining us today. Stay sharp, embrace the new technology. I know sometimes you might find it boring, but keep learning and keep loving. Hole hole ho jayega pyar. And once you understand the technology and you fall in love, then you won't be able to live without it. I know I have spent all of my life with technology, and even today I like to learn new stuff, new things. And this is why we at Ganpat University are pushing for innovation, innovation, and innovation. We need it so badly. It gives me immense pleasure to extend my warm welcome to every one of you on the occasion of Manufacturing Conclave of 2025 being hosted by Ganpat University. And I am glad that we are hosting it. Collective with the National Additive West, NAMCW, and the valuable support from the Ministry of Electronic Information and mighty Government of India. Like Nagarajan Sahab said, when we first met Chandrasekhar ji, it was a love at first sight. He had spent some of his life in America, and while I was here, so we had a lot of common friends, and he understood what we were up to, and he had no qualm about working with Ganpat University and allocating this Center of Excellence to the Ganpat University. Thank you, Chandrasekhar Sahab, wherever you are. God bless you. At Ganpat University, our vision has always been beyond the convention education and nurture the culture, innovation, respond, and aspiration of our nation. Today's universities are not just center of knowledge. They are catalyst and technology changes, shaping the industry, empowering the youth, and preparing the youth for greater tomorrow. There are going to be new challenges because the world is changing so fast. So what they are learning is not enough. They're going to have to be learning to learn so they can learn new things. And this is what we are all about. We are about teaching them how to learn and stay the student for the rest of their life. Friends, it is my own journey that from a small village of rural Gujarat to all the way to America in 1965, when not too many people came to US, at the tender age of 19 years old, and I struggled and fought and fought and fought, and here I am, have made a great progress in the technology area, and I want to give back to my nation. So this is all about giving back knowledge and technology and a true wealth of the nation. This conviction is a wealth inspired by establishing the Ganpat University. So the student of India, especially the rural background, could across the world opportunity and contribute to the growth of Indian growth story, which Narendra Bhai pushing so hard. When I see we are hosting National Additive Manufacturing Conclave 2025, it reinforces my own belief that our student and industry are ready to lead the world. They are not pushover. They can be the leader. They are the leader. We have led many industry in America. Why can we not do it at home? We should do it, and we must do it. We have no choice. Among the many transformative technologies shaping in our time, additive is one of them. Sometimes people call it 3D printing. It stands out as a revolutionary technology. It has many benefits, as we all know. I'm not going to go too much in detail, but I can tell you that it is uses in the healthcare, aerospace, electronics, and you name it, medical. We work with the automotive manufacturing. Tata Motors has become believers in Ganpat University. Maruti Suzuki has become our partner. We have no shortage of great partners, and we have won their trust, and we want to keep winning their trust, and we want to make sure that they don't lose the trust in us. So we're going to continue delivering it because we have a great team to do it, great infrastructure to do it. We have great support from the government to do it. In housing, 3D printing has made a great strides. In Chennai, they are printing out the home in 21 days. Can you imagine? It used to take 5 and 10 years to build a house. No more. There are many stories I can tell you that what used to take years and years and years now takes hours and days and months. So this is a great technology. I'm glad that we are part of it, and I'm glad that this partnership with the industry is taking shape on our turf. We are supporting the startup, industry, academia collaborations, future ready skilled workforce we want to provide to you. You tell us what kind of student you need. We want to give you the great student with the GUNI values, our value of Samvedna, Karuna, the hardworking, the integrity, honesty. Those are important virtues to us. And along with the latest technology, when you mix those technology with the great human values, then you get the wholesome product. And this is what we want to give to the industry, not just the body with the 98.4 degree temperature. We want to give a seamless technology. Many things we want to do for the industry. We are here only for one reason, and that is for the student. We have no hidden agenda. Ganpat University had no hidden agenda. I have no agenda. My money-making phase has been over. I am not here to make money personally or anything else. I'm not running for political office. This is the only thing that I want to do in my life. And this is what I demand from this university. And I want to thank you, each and every one of you, for joining us for a great cause. And I want to wish every one of you the best. Thank you. Jai Hind.
Thank you. Thank you very much, Dada, for your blessings. We now move to a moment of pride the unveiling of our souvenir AM imprints, a reflection of the innovations, insights, and milestones in additive manufacturing. May I request our dignitaries to kindly unveil the souvenir, please. Please give a big round of applause. Thank you very much, sir. On this special occasion, we also mark a new beginning of collaboration. We now proceed with the MOU signing ceremony. This milestone reflects our commitment to building partnerships that will strengthen the additive manufacturing ecosystem in India. I would like to invite the dignitaries from Ganpat University, Dr. Mahendra Sharma sir, and from the Instrumentation, Automation, Surveillance and Communication Sector Skill Council, Shri Brajesh Kumar sir. Please. All dignitaries are requested to please join. Thank you very much, sir. We are happy to share our next collaboration with the Sanand Industrial Association. We have Dr. Mahendra Sharma sir, and from the Sanand Industrial Association, President Shri Ajit Shah sir and their representatives. The objective of this MOU is to manage and operation of mini ITI to be established by Sanand Industrial Association.
Thank you so much, sir. So moving forward, today we have our distinguished guest, Shri Ajit Shah, with us. Sir blends industrial grit with visionary leadership, navigating Gujarat's industrial landscape as a developer, connector, and advocate. He's the best described as a catalyst, bridging players, building infrastructures, and boldly steering Sanand towards the smarter and more sustainable industrial future. We invite Sir to address the gathering. Please, sir.
Good morning. પરમ પૂજ્ય દાદા, થોડી સવારે મને સારું ન લાગ્યું કે સાંભળ્યું જ્યારે કે દાદા અહીંયા નથી. દાદા ઓનલાઈન જોડાવાના છે, કારણ કે લાસ્ટ ટાઈમ જ્યારે આઈ થિંક અમિત શાહજી અહીંયા આવ્યા હતા ત્યારે દાદા સાથે ઘણું ઇન્ટરેક્શન કરવાનો ચાન્સ મળ્યો હતો. પણ દાદા, તમારા આશીર્વાદ સદાય અમારી સાથે રહે એ અમે ઈચ્છીએ છીએ. હું આજે હમણાં આવ્યો ત્યારે બહાર મારે ચર્ચા થતી હતી કે એજ્યુકેશન બહુ જ વીક છે આપણું, અને બિકોઝ ઓફ પ્રોફેશનલિઝમ આવી ગયું છેલ્લા 20, 25, 30 વર્ષથી. તો એક વગર પ્રોફેશન જેમાં કોઈ પૈસાનો કોઈને જરા પણ ઇન્ટરેસ્ટ નથી, અને જેની પાસે પૈસાની એક સંતુષ્ટિ છે, એ વ્યક્તિ આજે અમેરિકા બેઠા આટલી મોટી યુનિવર્સિટી ચલાવે છે અને સ્કિલ માટે ને અહીંની ઇન્ડસ્ટ્રીઝ માટે એટલી મોટી ચિંતા કરે છે, તો ખરેખર દાદાને અમારા સાણંદના તમામ ઇન્ડસ્ટ્રીયાલિસ્ટ વતી હું વંદન કરું છું. મહેન્દ્રભાઈ શર્માજી જે સતત અમારી સાથે ટચમાં હોય છે, સતત એ ચિંતા કરતા હોય છે કે ભાઈ તમારે શું, જે દાદાએ હમણાં કહ્યું એમ દાદાના બિહાફમાં કે ભાઈ તમારે શું જોઈએ છે, વિચ ટાઈપ ઓફ સ્કિલ યુ વોન્ટ, તો એ બાબત અમારી સતત ચિંતા કરતા હોય છે. દાસજી સર કે જે સ્પેશિયલી અહીંયા આવ્યા છે આપણા માટે અને આપણને મોટિવેટ કરવા માટે, શ્રી ગુપ્તાજી, નાગરાજન સાહેબ, ખાસ એમને હું યાદ કરીશ કે જ્યારે અહીં મહેસાણાના કલેક્ટર હતા ત્યારથી હું ટચમાં છું કે સતત સ્ટાર્ટઅપની જે ચિંતા કરે છે અને ઇન્ડસ્ટ્રીઝ માટે જે વર્ક કરવા માટે પ્રયત્ન કરે છે, એવા શ્રી નાગરાજન સાહેબ, જીતેન્દ્ર પંચાલજી મારા વડીલ મુરબ્બી કે જે હંમેશા મને કહે છે કે આપણે લોકોની સેવા કરવી છે, હવે આપણે કંઈક સોસાયટીને આપવું છે. તો જ્યારે આવી બધી ડિગ્નિટરીઓ અહીં ભેગા થઈ છે તો અને એમની હાજરીમાં સાણંદ ઇન્ડસ્ટ્રીઝ એસોસિએશન જ્યારે એક મિની આઈટીઆઈ માટેના MOUs કરે છે તો ખરેખર હું ખૂબ ગર્વ અનુભવું છું આ બાબતથી. આજે અમને આ MOU કરવાના ચાન્સ આપ્યો છે, અમારી સાથે જોડાવા માટે. એટલે અમે જોડાયા છીએ ગણપત યુનિવર્સિટી. દાદા, હવે અમે તમારા ફેમિલીના મેમ્બર છીએ, એટલે અને દાદા તો સતત ચિંતા કરે ફેમિલી મેમ્બરની, એટલે અમે ઈચ્છીએ છીએ કે અમારે હવે કોઈ સ્કિલ બાબતની આઈ ડોન્ટ થિંક કોઈ બીજી કોઈ ચિંતા રહે. જ્યારે હમણાં જે વાત થઈ હતી કે આઈ થિંક નાગરાજન સાહેબે વાત કરી કે ભાઈ સતત આપણી સ્કિલને અપગ્રેડ કરવી છે, એના માટે શું છે તમે ઇન્ડસ્ટ્રી પાસે પૂછો. તો હું તમને ગર્વ સાથે કહું છું કે કાલે જ ગણપત યુનિવર્સિટીની ટીમ અમારે ત્યાં આવી ગઈ, મારી પાસે બધા ડેટા લીધા કે કેટલી ઇન્ડસ્ટ્રીઝને કેટલા સેક્ટરમાં, કારણ કે સાણંદ ઇન્ડસ્ટ્રીઝ GIDC જે છે એ કદાચ ગુજરાતની તો ટોપમાંની છે જ, પણ એની પાસે 54 MNCs છે ઇન વન સિંગલ ક્લસ્ટર. આ જે એમાં આપણી આ સેમિકન્ડક્ટર આવી ગઈ, બધી આવી ગઈ, પણ MSME ટુ MNC જો કોઈ ઇન્ડસ્ટ્રીઝનો એક ક્લસ્ટર પર જો વિકાસ થયો હોય તો એ માત્ર સાણંદ છે. તો એવી મોટી ઇન્ડસ્ટ્રીઝમાં જ્યારે એક ITI સ્થપાતી હોય, મિની ITI કન્સેપ્ટ કે જેમાં વિચ વિલ રન બાય ઇન્ડસ્ટ્રીઝ, તો એ બાબતમાં અમે પણ ગર્વ અનુભવીએ છીએ, પણ અમારી સાથે અમારે જે સ્કિલની જરૂર છે એ માટે અમારી સાથે ગણપત યુનિવર્સિટી આજે જોડાઈ છે. તો ખરેખર હું એમને ખૂબ ખૂબ આ યુનિવર્સિટીનો આભારી છું અને સાથે મળીને આપણે ખૂબ સારું કામ કરશું. થેન્ક યુ વેરી મચ.
Thank you so much, sir. So moving forward, now I would like to invite our guest of honor, Shri Sudep Gupta, sir, who is a former executive director and asset manager at ONGC Mehsana Asset. He has over 3 decades of rich experience across ONGC's key fields, including Karaikal, Assam, Ahmed, Cambay, and Bombay High. Sir is known for turnaround specialists. He has successfully led projects like the Nandasan initiative and managed India's largest onshore producing asset at Mehsana. Beyond operations, he has been widely recognized for CSR contributions, strengthening healthcare in North Gujarat by donating advanced medical equipments, mobile ICUs, and supporting community health projects. A passionate marathon runner, trekker, golfer, and cyclist, Shri Gupta embodies energetic leadership that blends technical expertise with social responsibilities. Now I would like to request Sir to address the gathering.
Namaste, dignitaries on the dais, of the dais, and online, and special my regards to Ganpat Dada, because of whom we are here. This university is here, so many students are here because of his contribution, because of his visionary leadership in the field of academy. And my special regards to Dr. Nagarajan sir. I think everybody will accept that he is one of the most industry-friendly brokerates we have ever seen in the government. And any industry setup would love to have a bureaucrat in the civil administration like Nagarajan ji. I had a long association, and really thank you, Nagarajan sir. You are not Nagarajan sir. You are not here in Mehsana, but as Ganpat Dada said, your heart is always in Mehsana, and you have stolen many hearts also. Coming back to students, it is always pleasure to come back to institutes and be among the students. We are also students. You are the students inside the campus, and we are students in real life. See, I am a mechanical engineer of 80s. During our time, manufacturing process means that conventional manufacturing process, what you call subtractive technology. The technology, the most advanced technology we heard in our days is numerically controlled machine, so that we can make some complicated shapes and all. So beyond that, we didn't know anything about this additive technology. But one thing I tell you, when I try to correlate, it is not that additive technology was not known to people of those days. See, our patola art, our embroidery, they are nothing but additive technology. The 3D picture is in the mind of the craftsman, and he adds on, wo jo dhaga bolte na, one by one thread he adds. If you go to patola, that patan, you can see they are the greatest additive technologists. Only thing, the modern technology, the computer and all those things have not come up those days, but they had that knowledge. Now coming back to the successful application, whether you call it subtractive technology, whether you call it additive technology, the key is metallurgy. The conventional technology thrived because there was huge research in metallurgy. And that is why so many products you can see in the market which came up through conventional technology. But for additive technology, you have to think differently. Metallurgy is more important here. We were discussing, you have to print with metal, and that metal, fusible metal, that properties of the metal has to be retained. When you do it in conventional technology, you manufacture the product, go for heat treatment and all those things. You retain the basic crystalline structure of the metal. But in additive technology, you have to fuse the metal to that temperature or whatever. You may go for powder technology or whatever it is. But then the end product has to have that metallurgical properties. That is very challenging, that is very important, and a lot of research is required in that. And it is not that people are not doing, people are, I think a lot of research is going on, a lot of products have been developed, but still I say that to take over conventional technology, it will take a lot of time, and students, you have a lot of responsibility. Until unless people do research in metallurgy, this kind of technology will not come up. Conventional technology could thrive because a lot of research went on metallurgy. And today I am very sorry to say, Ganpat Dada ko bhi main bolta hu, ki people are nowadays opting for only AI, earlier days IT or AI. Even those who go to core engineering like mechanical and metallurgy, at the end of the day, they all switch to IT or nowadays AI. Even my daughter, she passed out from NIT Trichy as a instrument engineering. Then she switched over to data engineering and then so many other things. Nobody stays in conventional engineering. The reason being, probably it's very difficult to establish. And then like today we are traveling with Dr. Girish. He was telling to come back to become a doctor of his stature, it takes a lot of time, it takes a lot of effort, it takes a lot of hard work. So nobody wants to do that hard work because easy money comes through technology. It's a white collar job, that is true. But then without the knowledge of core engineering, without the knowledge of metallurgy, no industry can survive. So I once again request all the students, please take the core engineering as a challenge. You have to develop, if India has to develop our knowledge in core engineering, our knowledge in mechanical engineering, knowledge in metallurgy, especially I am stressing on metallurgy, because I have seen as a person in oil and gas industry, metallurgy plays a key role. When you drill a well 4,000, 5,000 meter deep, the metal parts which you lower, the rubber elements which you lower inside in that depth, there is a huge temperature. You must have heard in newspaper that we have drilled a well in Ladakh area to harness the thermal energy from the ground. So because high temperature is there, now when you drill a well to that temperature under that high pressure and high temperature condition, you need different kind of metallurgy, you need different kind of composite materials. So those things are, research in those things, sectors are very important. And I think Ganpat University should encourage students to opt for those kind of research. Now coming back to CSR, as Madam told, Ganpat Dada, you will be very glad to know that when this is initiative, we opened up one Super 30 in Mehsana. And I express my sincere thanks to Nagarajan sahab also. He also encouraged us. We opened up one Super 30 last year, only in the field of medical, and I am very proud that I think 10 students, and all of them from very rural background, they got selected in government medical colleges. So it is not only, CSR in other fields, as you mentioned. I wanted to mention this sector also. Education is the key. If you give somebody money, money can be stolen. If you give somebody anything, any material thing, it can be stolen. But if you give education, you cannot, it will be with you for lifelong, and it will be the nuclear fissile reaction. It will multiply. One student from backward community, if he becomes educated, so it will multiply only. So what Ganpat Dada had done by establishing this university, he has created a nuclear fissile reaction. I think it is fissile reaction. So molecules are, atoms are being generated in the form of students, and the revolution goes to the entire country. So thank you very much for inviting me, and I wish that this seminar on additive technology will be a grand success, and students and as well as industrialists can take a lot of insights from this seminar. Thank you very much.
Thank you so much, sir. Now I would like to request Dr. Kiran Amir, sir, Deputy Pro Vice Chancellor, Ganpat University, to deliver the vote of thanks.
Good morning. Jor se, good morning. Yes. On distinguished guests and dignitaries on the dais, online and all, on behalf of National Additive Manufacturing Center, West Ganpat University, I take the opportunity to give a vote of thanks on behalf of and in the occasion of the inaugural of National Additive Manufacturing Conclave 2025. The dignitaries, in particular, the chief guest of today's event, Honorable Shri M. Nagarajan sir, the Vice Chairman and Managing Director of GSRTC, who has made it possible here online by joining in spite of his busy schedule with the arrangement of Honorable Prime Minister. We are thankful to him for sparing a valuable time here with us, and even you might not be knowing that when he was a collector over here, he used to sit with the students and he was encouraging the students to do innovative projects. So thank you, sir, for joining here. The guest of honor of today's event, Shri Sudep Gupta, the former Executive Director and the asset manager ONGC. Sir, thank you for encouraging the students, and the students, they are working in the live projects of the pipelining related at the ONGC, and they used to get the opportunity and visit at their own premises. So thank you, sir, for gracing this event. Shri Amir bin Ahmed, who joined online from the way from Dubai, and we appreciate the efforts who is putting on the betterment of the Ganpat University students. The distinguished guest, Shri Ajit Shah, the president of Sanand Industries Association. Actually, with this particular MOU which we have been a witness over here today, the students would get lot of benefit in terms of the industry and academia relations. So thank you, sir, for encouraging the students. We always get with the vision of Honorable President and Patron-in-Chief, Sri Ganpat Bhai Patil. Under his vision, we could establish this National Additive Manufacturing Center at Ganpat University. And the execution which was made by the action taken by Honorable Group Pro-Chancellor and the Director General, Dr. Mahendra Sharma, sir. So thank you, sir, encouraging and enlightening all the things for the betterment of the students. The distinguished guest, Sri Jitendra Panchal, for sparing, we are thankful to you for sparing a valuable time here with us. And mainly the sponsors, the partners, and in particular diamond, gold, and silver, because they have extended their support to make this event a grand success. So we are thankful to them as well. The distinguished speakers, panelists, and delegates who have graced this event and who would be also going to deliver as being a panelist, and who would share their knowledge across all the students and the participants. The organizing committee members, the university officials, faculty friends, heads of departments, dear students, and the participants, we are thankful to each and every one, because without your support and your participation, it would have not been possible to make this event a grand success. With this particular note, we are thankful to each and every one. Stay connected with us for the next round of the panelists, and you would get a lot of information with the discussion with this particular. If you have any doubt, you may connect with our internal committee members, as well as you can directly approach them as well. With this particular, we are thankful to each and every one. Thank you.
Thank you very much, sir. With this, we formally conclude the inaugural session. Now we will begin with the panel discussion 1 on the theme Transforming Automotive, Healthcare, Aviation and Electronics Industries with Additive Manufacturing within a while. The dignitaries are requested to please go off the stage, please.
Hello.
The participants are requested to please be over here. We are about to start the panel discussion soon. Students, please be over here. We are now beginning the panel discussion 1, which will be moderated by Dr. Kalpesh Patil, Executive Dean, Ganpat University, and Dr. Achyut Trivedi, Chairperson, NAMCW. Additive manufacturing or 3D printing has traveled an incredible journey over the past decade, from being seen as a rapid prototyping tool to now becoming a strategic enabler for high-performance, mission-critical applications. Today we are talking about industries where precision, reliability, and innovation are not just desirable, they are non-negotiable. From the cars we drive, to the aircraft we fly in, to the surgical implants that save lives, AM is quietly reshaping design, production, and supply chains. So let us dive and explore what it truly takes to transform these critical industries with additive manufacturing. I request Dr. Kalpesh Patil and Dr. Achyut Trivedi to moderate the panel. Please, sir.
Thank you, Dhaval bhai, and good morning, everyone. It's an honor to open this discussion on transforming automotive, healthcare, aviation, and electronics industries with additive manufacturing panel discussion. Additive manufacturing or 3D printing has moved beyond prototyping. Today it enables lightweight automobile parts for e-mobility, patent-specific implants for healthcare, fuel-efficient aerospace components, intricate electronic assemblies. What once seemed futuristic is now driving real industry transformation. The true power of additive manufacturing in design freedom, material efficiency, and its ability to accelerate innovation while supporting sustainability. At the same time, challenges we need to address is scalability, certification, cost competitiveness, and integration with existing production lines. This panel brings together diverse perspectives to explore not only the breakthroughs, but also pathways to make additive manufacturing a mainstream industrial reality. As we begin, let us view additive manufacturing not just as a technology, but as a catalyst for remaining products, processes, and entire industries. With that, I would like to hand over to Dr. Achyut Trivedi for welcoming our distinguished panelists and setting the discussion in motion.
Thank you, KP Patil sir. On behalf of the organization's team, it gives me an immense pleasure to welcome our distinguished panelists for this panel and our esteemed audience for this important discussions. The topic is transforming automotive, healthcare, aviation, and electronic industries in the domain of additive manufacturing. I warmly welcome each panelist and look forward for their valuable thoughts in this panel discussions. I'm confident that today's discussion will generate ideas that inspire collaborations, innovation, and practical impact. With that note, I'll invite the panelists. So first I would like to invite Dr. Girish Amlani sir on the dais. Please give him a huge round of applause. As said, the best surgery is the one tailored to the patients. Girish Amlani Saab has pioneered the use of additive manufacturing in the patient-specific implants and surgical planning. Thank you so much, sir, for your presence. Would like to request Dr. V.D. Patil to felicitate Girish Amlani Saab with the GUNI stalls, the memento and statement of gratitude. V.D. sir. So it's a memento printed in a 3D printing technologies that we are having at our national centers. Please give him a huge round of applause. Now I would like to request to join the panel to Dr. Vishwas sir. Vishwas sir is the CEO of MS. As said, aerospace and automotive don't just demand strength, they demand innovation at the scale. I would like to request Dr. C.P. Patil sir to please felicitate Vishwas ji with the GUNI stole, the memento and the statement of gratitude. Please give him a huge round of applause. Thank you, sir, for spending your time. Now I would like to request Mr. Krupal Chudasama, sir, to join the discussions. As said, every implant is more than a metal. It's someone's second chance's life. So with the expertise in the additive manufacturing, almost many domains from last few years specialized in orthopedic solutions, sir showcase how AM can revolutionize in the implants and the prosthetics and well. I would like to request Dr. Jignesh Mewada, sir, to felicitate sir with the GUNI stole, the memento and statement of gratitude. Please, sir. Please give a huge round of applause. Thank you, thank you. Moving forward, I request Mr. Rahul Gewala, sir, CEO of STPL, to join the discussions. As the future of industry is not built, is 3D printed, STPL is rightly in the path of making more and more indigenous technology. We would be honored to have your presence, sir. We would like to request Dr. H.A. Patil, sir, to felicitate Rahul, sir, with GUNI stole, the statement of gratitude and the memento. Please, sir. Give him a huge round of applause, guys. Thank you. As moving forward, I would like to welcome Mr. Franklin, sir, over here. sir works as an intersection of aerospace and healthcare more than the decades over there, and they're forcing how MSME can, drive the solutions. He always believes that in regulated industries, innovation survives only when it walks hand to hand with the innovations technology. I would like to request Dr. P.R. Patil sir to felicitate Franklin sir with the GUNI stole, the statement of gratitude and the memento. Please sir. Please give a huge round of applause. Thank you. Thank you. Thank you. Thank you for your time, sir. Now I would like to request our panelist, Mr. Vinay sir, to join the discussions. Vinay sir has been instrumental in helping industries integrating, advanced manufacturing solutions and overcome the barriers at a large scale, the problems in the domain of additive manufacturing. I would like to request Professor Mihir Patel from Marine Department to present the GUNI stoles, the statement of gratitude and the memento to Vinay sir. Please. Please give a huge round of applause. Thank you. Thank you, thank you. So now both the moderators requested to take their seats, and we are looking forward for a panel discussions. Yeah, thank you. Please.
Hello. So, good morning once again, and warm welcome to all the panelists. In the sectors like automotive, electronics, aviation, it's a shift from conventional manufacturing process to additive manufacturing. It is not just adopting a rapid prototyping tool as a technology, but it is a rethinking of design, production workflows, and supply chain management. UNIMAC has been closely involved in translating additive manufacturing promise into tangible industry solutions. So my first question to Vinay Srinivasan Dasji, in your experience, what are the biggest challenges in industry to face integrating additive manufacturing into existing manufacturing process, and how can companies like UNIMAC can help to overcome these barriers to achieve large-scale adoptions?
Yeah, thank you, sir. Thank you for inviting for this conference. So basically, the major challenge in 3D additive manufacturing, what we are facing is the conventional designs are made as per the conventional manufacturing methods in the mind. So the validation process of the material selection and the manufacturing aspects what they are considered. So it's validated over the years. So if you take just example in the aerospace sector, so one engine design, so from design to validation, it takes more than 10 to 15 years. Now India is developing engine from last 20 years. So the process which is selected or design taken into mind, and the part is proved after so many years of the efforts. So changing immediately and validate to the new requirement. So that is a major challenge what we are facing. Second challenge is the cost and the repeatability aspect. So the precision requirements in the aerospace sector is very high, where surface finish requirements, the tolerances are very high requirements. But what we see, how we can take additive manufacturing to the next level is the making awareness between the designers, industries. So industries still don't know how additive manufacturing can be used into the design aspects, and similar to the way they have designed the conventional manufacturing products. So that awareness needs to be created, and I think you are doing great job into that. So that way we can take it forward to the next level. And one more aspect is that we don't need to think that additive manufacturing will replace the conventional manufacturing. It can jointly work as together, because you can see for after additive manufacturing you require post-processing and all, or some of the features where conventional manufacturing is not feasible, but we can do together with the conventional as well as the additive manufacturing, it can make to the successful.
So very well said, sir. As you said that additive manufacturing is not the fully replacement of the existing technology. It's just it can complement with the existing technology. So that's a real takeaway. I would request Achiji for the next question, please.
Yeah, thank you, sir. Exactly, you mentioned that, additive manufacturing should complement the traditional manufacturing over there. And of course, there is a need to accept the industries about how this technology can withstand, and then they can adjust in their existing setups as well. So with that note, would like to ask Vishwas ji that as they are doing lot of things in the terms of the indigenous technology to make it more industrial adopted rather than going for that technology. So especially in the domain of like you're done in powder-based fusion or something like that. So if you can share some of the most impactful, developments that how this additive manufacturing can deploy into various industrial sectors, and how MS is doing the work, and how you can contribute for the same, sir. Thank you.
Good morning. Thank you so much for inviting us for this event today and this panel discussion. To answer your question, India historically has been lagging in catching up to this technology. Manufacturing wise, India has been quite advanced, but when it comes to additive, traditionally we've been a little slow because we are a little risk averse as a country itself. So when you look at it, in the past, this technology was a Western adopted technology. So the machines, the material, the program, the application, the end user used to be largely a Western driven one. Whereas now in these past 5-6 years, we are seeing a great improvement in adoption to indigenize technology. So we are seeing machines being made in India. We have raw material which is being developed in India and qualified for airworthiness, for defense applications and many other critical applications. A lot of engineering effort is being put in India by manufacturers. So if you see one of the most researched or most time spent work both in West and now in India is conversion of applications to be made suitable for additive, continuing on where my colleague from Unimec just explained. So that is a huge science that's going on right now, and not to mention the entire process chain to finish those parts in India. So today there's a lot of transformation happening, exponentially growing in these past 5 years that we are seeing that is happening. Coming to Amaze and what we are doing, we are an indigenous, we are an Indian laser powder bed fusion machine manufacturer, and for us, some of the most prestigious projects that we've implemented are with the DRDO, where they took nearly about 1.5 years to qualify some of the parts that they wanted to be done, very critical missile components that they wanted to qualify on our machine. And once we were able to prove them to be as good, if not better than some of the Western counterparts, they decided to qualify us for technical suitability. And today our machine has been printing continuously for the past 2.5 years at DRDO's DMRL facility. Similarly, in ISRO's VSSC, they again had certain very critical applications for the space and the rocket parts of some of the structural parts. There again, after a continuous process of qualification, we were able to prove them our worthiness, and today the machine has been printing for again about 1.5 years. And again, from the government perspective, more recently we have NCAM, which is National Center for Additive Manufacturing in Hyderabad, who again went into qualifying the machine, understanding the suitability for their requirement, and they have very interesting projects lined up going ahead from both private sector and government sectors to be onboarded and to be developed. Coming to private sector, we have some very stringent mold manufacturers, both from a forging industry. We have a customer in Chennai called Super Auto Forge who has onboarded two of our machines, one after the other, because the first one is completely booked out to print forging die inserts. Imagine forging is a very critical process with heavy loads coming in. So they have taken machines one after the other, and the machines are completely booked out to print continuously because they have seen worthiness in these technologies. So like this, there are many others who are continuously using our machines to print, be it in the defense, aerospace, or private industries, automotive, prototyping. This has been growing exponentially in these past few years because of the local adoption and some of these early adopters who believe that this technology is worthy. They're taking the risk, they're making the effort to invest time, effort, and money into this technology and provide it the right limelight that it needs.
Thank you, sir. So for all our industrial audience over there, what sir is mentioning about, you know, the basic, the affordability part is somehow that MS is taking care of that to create an ecosystem starting from powder development to testing to manufactures under a single roof when we talks about metal additive manufacturing, right? Thank you, sir. I would like to talk to KP Patil, sir, to move forward.
Yeah, thank you, Viswasji, for sharing your thoughts. Obviously, additive manufacturing is very much useful in aviation, even aerospace and defense sector. There is a major role of this technology in healthcare sector also. So today we will discuss with the usefulness of this technology with Shri Girish Amlani ji. Sir, in healthcare, the shift from standardizing the solution to a patient-specific care has been accelerated by 3D solutions. Few areas showcase this better than the reconstructive or aesthetic surgery, where precision, customization, and time to treatment are very much critical. So can you please share how 3D printing is impacting surgical intervention, especially in aesthetic surgeries?
Thank you for inviting in this conference. Mr. Asit Trivedi used to meet me in Rajkot where I was practicing. I did around 10,000 cleft lip pellet surgeries, and there, with help of 3D printing, we developed nasal conformer. In international market, it's available, it's very expensive, but we made it at very cheaper rate, and we used to give free to my patients. And after that, I made it of silicone with making die. But if now, with 3D printing, if we can develop this nasal conformer of silicone, then we can give customized to the patient of same size and shape what is needed. Here we have made with dies, we have made of 3 different sizes and we fit in the nose. But if we use 3D printing, then for each person we can customize the nasal conformer and give it to the patient. So it will be more effective. Then comes to in rhinoplasty, we are using cartilage, bone to enhance our shape of the nose. But if we use this 3D printing for silicone graft, then we can give better shape to the patient. And at the same time, we need not to harvest their patient's own tissue. Because if we use own tissue, we give a lot of scar there. So it's best to give 3D printing and use the silicone material. For breast reimplant also only few sizes are available, 200, 250, 300, 350. So if patient needs 220, then they are just stuck there. So if we use 3D printing for breast implant, hip implant, mandible, hemi-mandible replacement, then I think it will give a lot of better cosmetic to the patient.
You rightly mentioned, sir, that it is very much useful in plastic surgery,
yes.
Aesthetic surgery.
Yes.
Not only that, it can be also useful for a sort of a predictive surgeries, like before continuing any surgery, we can have a model on which the practice can be performed and actual surgery can be done in a better way. So thank you very much for sharing your thoughts. Would request Achiji for the next question, please.
Yes, thank you, sir. Thank you. As sir rightly mentioned by you, that there are the surgeries in terms of plastic, surgeries that are needed of additive manufacturing. Now, so moving forward, Krupalji, as you know, orthopedic care is also one of the promising application areas when we talk about the outer parts or inner part of the operations over there, where tailor-made implants are very critical in terms of healthcare, and additive manufacturing are serving for the same purpose. So how as Orthomax utilize additive manufacturing in creation of customized implants devices, and how these implants have you seen in the outcomes of the patients? Also, if you can share some of the economical aspect of, well, as there are some myth about when we go about the customized, of course the economical factor also plays a huge role. So if you can share some of the lights on the same, sir. Thank you.
Hello. Mr. Achuji, thank you very much first of all to invite me for this. And regarding the Orthomax, we are the manufacturing the craniomaxillofacial implants and also for the trauma plates, nails, and some of the prostheses. And today's generations, you are already aware that people are moving towards looking like more and more attractive to facial surgeries kind of thing. So we are receiving some special requests from patient-specific implants. So for that, we are receiving the DICOM data. Based on that, there are so many communications going with surgeons, and with the surgeons' guidance, we are designing the implants for the biomedical engineer. And then when if we will directly 3D print the implant, it will create, it will not get exactly what they are going to requirement. So what we do, mostly we do 3D print the bone and also the plate. The bone and implant both has been 3D printed and supplied to the surgeon, and surgeon can have the actual idea what will be there. And for some medical devices also, when we are developing medical devices, some nasal sprays kind of thing, and some insulin pen kind of thing. So if I talk about the previous generation, so many past years ago, there are not all materials are available. We can give the actual, what will be the actual scenario. But today's, there are so many actual things are available. And regarding the prosthesis, yes, as just rightly mentioned that 3D print, Dr. Girish has rightly mentioned that we need to use 3D printed implants. And you also mentioned that what will be the economic way. So it's all about the balance between time and money. So the cost and time both will be the same way. We need to balance in between. Patient-specific implant, yes, we can do that in the time manner. But for the another specific implants, which will be the general implant with the different size, we are manufacturing with the regular method.
Thank you, sir. As you rightly mentioned that, along with the implants printing, surgical planning using additive manufacturing is also a very critical area to work. Yeah. So I would like to request KP Patil for the next floor.
Yeah. Thank you, sir. Actually, we all are aware about certain additive manufacturing technologies, and FDM is the most versatile technology we are knowing as in a plastic 3D printing, we can say, as well as SLS in the metal printing. Right now, SLA technology is also setting up the benchmark in terms of quality, precision, as well as the application versatility. So today we will discuss with Mr. Rahul Gewalaji from STPL. Sir, would like to know from you that what are the critical breakthrough applications using SLA or DLP in sectors requiring high precision, such as healthcare or maybe electronics?
Yeah, that's a very interesting question. Let me give you a little background of what we are doing. We are at such a sweet spot wherein we have experience of working with more than 20,000 laser installations by us, made in India machines since 1993. We have a fully functional coronary stent manufacturing division, and they are into very innovative products. And we have certain incubation projects also going on. So we got to develop some very unique products for our upcoming projects, as well as for some of the most brilliant mind of the industry. SLA and of course SLM, both the technologies are going to be the next sweetest industrial application provider. For medical and healthcare, of course, customization, because every body, every human is unique, every need is unique. So customization is the key. Now, if I extend that thought, the affordable customization will be the way to success. And then you add the fourth factor, the timely delivery. So we need user-friendly, affordable, fast machines for India. That is what we are developing. I would like to share one success story. We came up with a problem statement that one of our incubation project, they were developing a heart parameter monitoring sensor system. Objective was to develop the whole sensor system along with wiring everything, circuit board, within 0.1 millimeter diameter. With conventional technology, they gave up. They said, cannot be done, after spending like more than a year researching or negotiating with other companies. So we developed highly specialized machine by which they were able to print 0.05 millimeter, that is around 50 to 70 micron size sensor on the tip of 2 meter long wire. And thanks to this customized machine and 3D printing technology, we converted the whole wire into circuit board. That is how we created this very innovative product. It is in a very advanced clinical trial stage, and very soon it will be available from overseas market, then we will enter India. So that is the power of indigenous 3D printing technology. So coming back to your question, I mean, it has immense potential with advancement of new technology. For example, very tiny muscle-like material for grippers, for actuators, for biological application, for clinical applications. We are developing very tiny heart pump, which will be catheterized into heart. Now this kind of technology cannot be, I mean, this kind of application cannot be met without advanced 3D printing or boundless manufacturing capability. And that is where the true power of additive manufacturing comes in. Thank you.
Yeah, you rightly mentioned, sir, the time-bound, affordable customization is very much important, and that can be done with the help of this sort of technology. So thank you very much for sharing your views. I would request Achiji for the next question, please.
Yes, sir. Sir, you rightly mentioned that, you know, how SLA technologies are growing, and they are serving this well. So as there are many SMEs and MSMEs industries, people are also there, sir. So I would like to request Franklin, sir, to share some of the thoughts that, you know, as sir, you are working in these domains and majorly serving the SMEs and MSMEs with the dedicated, you know, project definitions and all where in the most of the sectors. So how balance innovations while compliance serving both sectors like aerospace or healthcare, or right, and what role do MSME play in this journey, that what we can say in the additive manufacturing technologies?
So first of all, thank you so much for inviting us, and it's really a brilliant question, because compliance and innovation always contradict each other, and Dr. Vishwas can agree, because when he is developing Indian make machines, he has to make standards and the compliance for the European norms, but he need to add innovation there. So it's really a tough part for a compliance management, and we as a company, we are into the service bureau. We simply call it as a contract manufacturing, and we work for healthcare and aerospace. Predominantly we are into the patient specific implants for the maxillofacial and orthopedic. We work on it. Now compliance with respect to aerospace or the healthcare is the data privacy, the first thing. So data privacy, aerospace guys will talk about that, how you protect the drawing, what is the version you are going to handle. So you need to have a different kind of people to compile to the aerospace norms. comes to the healthcare, Giri sir can accept, how you take the patient's data, it should not go out of the data. And you make a product which is an individual. So I am trying to make, say example, a plate which is a unique and I want to innovate something. If I want to put it in a LinkedIn or I want to publish something, I cannot reveal the data. I need to go to the ethical committee, get the clarity, approval, and then release the paper. So always the innovation and compliance have a problem. Second one, with respect to the what we talk on the data management side is fine. Now comes to the risk assessment. People say aerospace is always a risk assessment. How you go for a risk? But in healthcare, we make one product, one life. So that's more riskier than the aerospace. Mass transport, it takes off and lands. So people go about 90% of the document you need to create for the aerospace. Only 10% is the work you are going to invest on this. So as a company, we always struggle whether we go with the compliance management side or you go with the innovation management side. And if you see in India, there is no large-scale company has invested in additive manufacturing. It's only the MSME started proving the concepts. MSME started getting into the involvement of low-volume requirements. Why large-scale companies are not there? Because they want to get into the high-volume production, make a larger production line, small margin, but big money into that. But small-scale industries get into this. So rightly, Ganpat University is trying to sort out the concept proving. From there, you are trying to build the industry. Then the industry will drive on the large-scale investment. I hope so in another, down the line of 5 years down the line, Reliance will have definitely additive centers. Siemens will have additive centers. So as we think, as he rightly said that, subtractive manufacturing and the additive manufacturing will go parallel together. Because we as a service bureau, we get a lot of inquiries, a simple plate, they come and give it to us, can you print it? Then we say, okay, I will print it, I will charge you, say, 8,000 rupees. Then say, Hare sir, 100 gram part, aluminum part, you are asking 8,000 rupees. A simple mathematics. Aluminum per kg plate is 400 rupees conventionally. You buy a powder, a per kg powder is 2,400 rupees. Where is the cost comparison? So MSME is always into the risk of pricing. So how a MSME can play innovation here? That's one. Secondly, morning, one of the person was talking about the metallurgy. Metallurgy plays a very, very critical role. See, today I print, say, stainless steel component in nitrogen as a gas flow. Then compliance management says that no, argon you have to use. So cheapest version is nitrogen, argon is the compliance one. Which one I need to follow now? So this is again a complication of innovation and the compliance management. But finally I want to end up saying that compliance is must, because you need to have a data protection, you need to have a risk management. So we have to compile with certain things. By getting into the shorter version of innovation and makes better thing. And MSMEs like us are ready to support all the contract manufacturing, ready to take risk by proving the concept. Example, the two companies are here. One is in the plastic side, they have already taken a risk. Another one is on the metal side, already taken a risk and proving it. So that is how we are moving forward in the MSME. Hope the large scale company will not take over us. Thank you.
Thank you. Thank you, sir, for sharing your thoughts, sir. Sir, as you rightly mentioned, I would like to say some technical thing that the purpose is to just to use the shielding gas. Now, rather it's a argon or it's a nitrogen, there is no doubt about the same, right? Yeah, so I would like to now request to summarize the whole discussions to Dr. Bhavesh Patil, sir. Bhavesh, sir.
Good afternoon to everyone. Ladies and gentlemen, as we conclude our panel discussions, a few clear messages emerge. Additive manufacturing has truly moved beyond prototyping to become a transformative force across industries, whether in aerospace, defense, healthcare, automotive, or electronics. What we heard today is that additive manufacturing is not just about adopting a machine, but it's about rethinking design, workflows, and entire supply chains. Our panelists shows us both the promise and the realities. Breakthroughs in high-performance aerospace, life-saving applications in surgery and orthopedics, precision in electronics, and the vital role of MSMEs in building agility and local capacity. At the same time, challenges of scalability, cost, compliance, and workforce capability remains. From the policy and ecosystem side, we learned that building a skilled additive manufacturing workforce, embedding sustainability and digital intelligence, and aligning skill frameworks are critical for mainstream adoptions. Collaborations between the academia, industry, startups, and policymakers will be the true drivers of India's additive manufacturing journey. In short, India is not just adopting the AM, we are shaping an indigenous, inclusive, and globally competitive model of innovation. The road ahead demands continuous collaboration, sustainability, and bold thinking. On behalf of everyone here, I thank our eminent panelists for their invaluable insights and the audience for engagement. Let's carry forward today's energy to accelerate India's leadership in the additive manufacturing. Thank you so much.
Thank you very much, sir. With this, we formally conclude panel discussion 1. Thank you, Dr. K.P. Patil. Thank you, all panelists, and thank you, Dr. Achyut Trivedi. Our next part is panel discussion 2. Yeah, please. Thank you, sir. Now for the keynote address, we are having Shri Ravi Patil, sir, General Manager, Design Tech. The topic for the keynote address is Accelerating the Future of Industrial Production. I would invite Shri Ravi Patil, sir, to deliver his keynote address. Please, sir. Thank you. PPT is already there. Sure.
कॉलर माइक है कॉलर माइक हैंड माइक दे हैंड माइक
Hello. Hello.
Yeah. PPT. Very.
Hello. Yeah. So good afternoon, everybody. My name is Ravi Patil. I'll be talking about additive manufacturing, accelerating growth. So today morning onwards, we have been talking about a lot of things about how additive manufacturing is playing an important role, how it is being used across industry. One of the things that I just want to talk about is my friend Franklin here just mentioned that he gave a case study wherein somebody comes to him and asks him to print a plate, which is conventionally at a very low cost done. So one thing that is missing out in additive manufacturing is DFAM. Now, what is DFAM? DFAM is designed for additive manufacturing, and that is missing. Because most of the conventional or educational institutes, they always talk about conventional designing. DFAM is something that is missed out. And then you just take a part which is conventionally designed for conventional manufacturing, and then you ask you to do it into additive manufacturing, it's not going to work. So it's not going to work, okay? So you need to understand how an additive manufacturing process works, and then design your product accordingly. That is very important, and that's the key thing that has to be used. Now what I will be doing through is, I will be going through various slides about how additive manufacturing is used by various domains, especially automotive industry, and then we will see that. Also, I have added one last slide in my presentation based on the information that I got that we have some colleagues from medical industry here. That's the reason I have added one last slide on medical, because if I have to talk about medical, it will be like a 2-hour session if I have to talk about how additive is going to work on medical. Okay, so only one slide, but definitely we can have a one-to-one interaction and see how it helps. Additive manufacturing, when we talk about, is the first thing that comes to your mind is prototyping. Everybody talks about 3D printing, and 3D printing is nothing but prototyping. But 3D printing, prototyping is not what we are talking about, because there is no growth in that segment. Prototyping, if I have to do a prototyping and then my variation is like 1 mm, I'm still okay because it's only visualization purpose. So we are not talking about prototyping because the growth of additive manufacturing is into other segments. So we will see those things. And before I go into it, I'll just brief about our company. So I'm from Design Tech. We are basically 26 years old company. We have got around 8,000 plus employees, offices across India and out of India. So that's about our company. Just a minute. Not working. Yeah. Talking about Stratasys. So basically Stratasys is 30 years old company, started by Scott Crump in 1988 onwards, and then over a period we have gradually had multiple technologies, multiple materials. I myself, I have been associated with Stratasys from 2006, last 20 years, roughly around 20 years I have been only working on additive. I have seen machines working with single material, single color, and manual Z leveling done on the machines to the automated one which are there right now. So that's about Stratasys. Coming to the challenges, and I'm sure these are the challenges all across, irrespective of the industry. These are the challenges. India is on a global market, so there is a huge demand for all the materials that are being produced or all the products. Decreasing weight is another challenge, lowering machine cost, material cost, and automatic production line. These are the challenges which are faced globally. Now, very important thing here is the cost of the product has to be reduced. That's very important. But at the same time, the quality control has gone up. They need high quality parts. They are not going to ask you that, okay, the cost is reduced, so we are going to agree for a lower quality. No, that's not the case. In fact, it's reverse. They want a high quality part at a lower cost. So this is something which is a challenge. Reducing cost, reducing weight, these are the challenges. And to address these challenges, Stratasys is pioneered or is well suited with all multiple different technologies. So we have got technologies from PolyJet, FDM, Neo technology, which is an SLA, powder bed technology, and a DLP technology. I will run through few of the slides, not going to go into a depth depending upon the time concern. So let's look few of the things. FDM is one of the most versatile. You already have FDM machines. I'm not going to talk about how it works. All of you know it. The best part about Stratasys FDMs are the materials, because that is something which is very important. Today on morning we have been hearing this, that materials are important, metallurgy is important. Now we have got materials which can be useful or used in different applications. Now applications, remember the word applications. It's not prototyping, it's applications. One of the applications is this. I'm not sure how many of you have used this application in FDM. It's embedded inserts. So typically if anybody is into drones or into automotive, this is a very vital application from them. What you can do is, the machine is printing your part, you pause the machine, open the door, put a metallic object on the part, close it and resume the printing. The part will get embedded. Now this is very important if you are talking about embedding RFID, embedding electronic sensors. The other day I was at Hero MotoCorp. In fact, yesterday I was at Hero MotoCorp and we were talking about a keyless entry for a vehicle. The key could have an RFID. You just walk towards your two-wheeler and the two-wheeler, it's ready to start. You don't need to have a key to start it. So that is what we were talking yesterday at Hero MotoCorp, and this is something which is done with Stratasys printers. Now there is a typical application. Here's application. The same application is used by one of our customers who is making ACs, and if you see the center portion, those inserts are embedded during the build. They are not heat set afterwards. You don't put those inserts afterwards, because if you put it afterwards, it might go wrong. And this is the testing that they carry out. You see the fan impeller. Because of that embedded inserts, it's concentric, and then the testing is perfect as per the requirement. Next, as I said, we are talking about multiple applications, and this is the application that is very much of interest. Manufacturing aids. It's no longer prototyping. We are talking about manufacturing aids, forming tools, and end-use parts. That's the key area. And again, remember, DFAM is the thing that you always have to have it in mind if you're talking about additive manufacturing. Of course, prototyping is there. People do prototyping. If you want to develop new products, you want to launch a new vehicle, you do prototyping. That is there. There is no denying about that, but it's okay. But the thing is this. Now this is something what is the most important, and this will give you the real benefits of additive manufacturing. Now if you look at this example, now this is again for an automotive industry, which I have worked with them for this project. Any automotive industry, can you tell me how many jigs, how many fixtures are required, measurement fixtures or inspection fixtures, if a new automobile is to be launched? Typically, I will give you the figure is roughly around 600 to 700 fixtures are required, only inspection fixtures, if a new automobile is to be launched. And this was a fixture for a tail light inspection. Traditionally, they were doing this fixture having after 100 hours of machining, a 75 kg aluminum block was machined out. 100 hours machining, machined out, and then they used to get a fixture which was weighing roughly around 2.3 kgs, and the cost was 1.5 lakhs. 100 hours of machining. Same thing was done using additive manufacturing. We did the same thing, absolutely no change in that. Same thing we did it, 34 hours flat. 34 hours, end product 800 grams, cost 30,000 rupees. Just imagine what is the difference. We are talking about 1.5 lakhs in traditional, we are talking about 30,000 in additive manufacturing. Now when I say this, it does not mean that we are going to replace everything which is conventional. No, it's not that. It has to be, it is geometry oriented, lot of things are going to go into it. And you have to understand and identify which geometry is suitable for additive manufacturing. Not all geometries are suitable. That is another key area. Identification of the part. Just it is there and so I have to print it using additive, it's not going to make sense. You need to identify it. And this is where the basically industries are finding benefit using this application. Now this is another application. This is to showcase the strength. Now if you see the center portion, the center black portion, that is made out of nylon 12 CF. Traditionally this was made using metal. This was a metal part and this was again automotive industry. So what we did was we converted the metal using additive manufacturing using a nylon 12 CF. And the best part or the worst part, whatever you can say, is this part is going to be loaded with a 300 kg engine. I am talking of 300 kg engine loaded on this part, and this is the first thing that goes into an assembly line and the last thing that comes out of an assembly line. This is where they are loading the engine. You can see the engine being loaded on that part and it could withstand that load. It's a huge engine, by the way. So once this was done, the entire thing went into an assembly line. We were 2 days on the assembly shop because everybody was afraid we have converted a metal part to a plastic part and whether it will sustain or if there's going to be any mishap. 2 days we were there with them, we were moving along with it, and then after 2 days they said, okay, this works fine, we can use it. Because this is how it is, because people are not ready to accept change immediately. We have to showcase to them, we have to prove to them that there is a possibility that can be done. Another fixture, end of arm tool. Now this is basically a traditional fixture where you have it at the end of robot to cut metals. So this is a fixture which they developed using additive manufacturing. Have a look at this. Yeah. Just a minute, sound, audio. Audio for this. Audio.
Genesis System Group manufactures work cells with robotic arms. We are primarily a welding group and have ventured out in the last 2 years into the aerospace world in the ultrasonic inspection of carbon fiber parts as well as the water jet cutting of carbon fiber materials. The end of arm tool, or the end effector, is the device that we mount to the end of the robot to be able to pick up a part or weld parts together with. About 18 months ago, Genesis developed a water jet cutting cell that we in-house call our razor jet system. We developed a end of arm tool out of the FDM material to pick up a customer part. Once we pick that up, we're able to take that underneath the water jet and cut the part with the water jet while holding it with the FDM gripper. So when we started the development, we wanted an end of arm tool that was vacuum, that was quick, cheap, easy, and durable and repeatable enough for the water jet application. So our designer worked with Stratasys to develop this end of arm tool that has a port all the way through for vacuum. It provided an easy, quick way for us to pick the part and take it to the water jet.
So this design allowed us to incorporate a vacuum, and we didn't have to use any outside tubing. We were able to create the vacuum within the part. All we had to do is add a POP suction cup, and it easily created a process that otherwise we would have to use a lot of outside vacuum tubing, and it would probably be damaged by the processes in which we were running parts through.
Normally it would take weeks to get parts manufactured or made. With the FDM gripper, you can have a new end of arm complete and bolted up to the robot within a day or so. So there's quite a bit of cost savings as well as time savings. In comparing the durability of the FDM parts to the traditional grippers that we use, the FDM parts hold up in the inspection world just as well as the traditional manufactured grippers. The Water jet is a much harsher environment, but we're still able to get the cycles that we need out of that FDM gripper. With the use of the FDM material, it allows our designers to think outside of the box a little bit more and produce something that's specific for the application versus having to design around the manufacturing environment. It allows quite a bit of flexibility for them to be able to do that.
It's a more enjoyable process. I get to design parts that are more organic. I don't have to work with block material.
The FDM parts have allowed Genesis to provide a unique service for the customer that not all of the integrators that they deal with would normally have. They have the ability to now print and manufacture these things quickly versus the traditional approach of manufacturing, machining, and assembling all of the end-of-arm tools for the robotics.
So 20 days, 3 days. That was the thing. So you need to identify what can be done. Additive manufacturing can do a lot of things. There are no constraints, but very important is identification and very important is designing for additive manufacturing. Once you are clear with those ideas, then the next thing that comes to your mind is which technology to be used. Not one technology does everything. Not FDM. FDM will not do everything, SLA will not do everything, or SLS will not do, or a DLP will not do. You need to identify which technology is suitable for what type of part. This is a very interesting case. This is something I love to show you. Always I am an engineer and we have learned so far that we use metal to deform plastics. That is what we have learned over the periods, but here he has used plastic to deform metals. So that's interesting. That's the reason I always love to show this. So you see those molds, those are printed out using thermoplastics, and that's an aluminum blank which is using to deform. The PC, these are molds using polycarbonate, and polycarbonate molds to deform an aluminum blank. Here's a small video which shows you which is used in a bigger press, not just a smaller one, a bigger one. Audio.
Very close to delivery, the tooling had been damaged and was no longer usable, and all of a sudden they had to figure out how we're going to make this part. My engineers sat down with the sheet metal fabricator, and in a couple of days, in one iteration, we printed a full-size forming tool out of a nylon 12 CF. It was a lot of bets going on, I think, of whether it was going to work or not, but it worked fantastically first time. It allowed us to save a significant amount of time, and we did it very economically. It was a short-run job, so instead of spending a lot of money machining tool steel in a very complex geometry, we could print it and have the parts in a couple days. The best thing about additive manufacturing is part complexity does not affect either time or cost, which is a huge savings to us because it allows us to think really broadly about how we're going to approach a design.
So you see, again, it's not just a plain simple forming, it's a huge press in which they have used this to deform a tool. Now, geometry constraint is there. Now, going to the next technology, that is what we talk about is polyjet. Now, polyjet uses photopolymer resins, and the best part about polyjet is it can mix materials. So it can mix rigid materials with rubber to give you different shore hardnesses. It can mix white with black to give you different gray shades, or it can mix any materials. So it has got different materials that can be used, and this is specifically used for styling and medical. This technology is used a lot in medical industries. So another best part about this technology is it can give you Pantone shades. Now, what is Pantone? I'm sure all of you know it, but one of the examples for Pantone what I usually talk about is if I want to choose a blue color, blue for me could be something else, dark blue, or blue for you could be a sky blue, but it's a blue. But if I'm going to talk about 801C, globally it is 801C. There is no change in that color. And with polyjet technology, when you bring in your part, you right click and you say that, okay, you want the part color as 801C, it is going to print it in 801C. You can have multiple Pantone shades. It can roughly print around 5 lakh colors. So anything what you want, you can print it in rigid, clear, rubber, shore hardness, any color, any texture, it can do it for you. This is a case where Audi has used this technology to develop a new tail lamp, and you can see the tail lamps which are printed using PolyJet as a technology. It can give you clear parts, and it can print it conventionally 1 to 2 weeks, traditionally 5 hours to 48 hours. Just see the difference, 1 to 2 weeks, 5 to 48 hours. Now this is where the ROI is. It is not just the cost of the part. It is the cost of your person sitting on bench for 2 weeks just to get a part and then work on it. But if he is able to get the part in 48 hours, he is going to work more, and that is something which will generate an ROI. Again, Mini Cooper, another example. Now this is not at hit India, but definitely it will come to India. I walk into a store and I say, I want my vehicle to be customized. I want the name of my wife or my kid written on the vehicle, on the bonnet, anything. I can get it done. Today it is not possible with conventional, but with PolyJet, you can just print it, put it on your vehicle, and you are ready to go, whatever you want. Customization is something which is very, very useful, and PolyJet can definitely help you in getting that. See this. This is a new development, instrument cluster for a vehicle. Everything is printed out. You can literally see a realistic feel. The digital data, the side map, everything printed out in one single go. There is no poster or sticker, anything, it's printed out. We can print out in any textures. You want a cloth texture, a leather texture, any texture you want, we can print it out. You can print it out in any colors. Going ahead, next is the origin technology. Now this is the DLP technology. The best part about this is the parts out of this technology will be an injection molded finish part with an accuracy roughly of 50 microns. Now this technology is used for batch manufacturing. Let's say you have something which has got a requirement of around 10,000 pieces, Origin can definitely help you in that. Yeah. So we have different materials. It can withstand rubber-like material, high temperature materials, and these materials are not from Stratasys, but from third parties like Henkel, Loctite, BSF. You can see connectors and all. Just look at one of the connectors. 33 parts were printed in a time span of 1 hour 45 minutes. Now that is something very useful. 33 parts, 1 hour 45 minutes. If you are developing a new connector, just print it. Don't wait for the mold. Just print those things. Okay. Can be used across the segments, gaskets, sealings, handle grips. You can use it across. Next is the SAF technology, selective absorption fusion, where it's a powder-based technology. You can use this to print different components, again for end-use parts. Let's say your requirement is 20,000 pieces, 30,000 pieces. This is a technology which can definitely help you. It can print in polyamide. It can print in nylon, and it can print in polypropylene as a material. So here's an case study from Roche. Now they customized cars, and they wanted to have a camera mount fixed onto a vehicle, so they just printed it. Have a look at this case study.
Raj Performance has been around since 1996. We actually started as an engine shop, building racing engines. So really at our core, we are an extreme performance company, started in racing.
We develop vehicles for our customers, from Mustangs to F-150s that suit their lifestyle. We're a team of dreamers, doers, and enthusiasts that love what we do and live what we work on. Everything is special about a Roche vehicle. It's the feeling you get when you get behind the wheel, from the exterior appearance to the rumble you get when you push the start button. Roche has been using 3D printing since the early 2000s. The biggest benefit of 3D printing here at Roche is definitely the time savings. The time for development and taking the tooling or trial period down to a fraction of what it is in traditional methods is a huge benefit. On the F-150 project, we had a late design change that we had to pivot very quickly on. We had to reposition the front camera on the trucks, and in doing so, the solution that we came up with and thought, hey, we can mock this up and try it, actually ended up being our production solution for the program.
The reason we went with 3D printing is because of the time issue we had. We already had trucks in our facility to be built. We had product already there, all the grills. We leveraged our existing relationship with Stratasys, and that's where they introduced us to the SAF technology on the H350. The advantage to using this technology was we could get our prototype parts as well as some PPAP parts potentially in the same build, and that supports our production volume.
We're able to take a 3 to 4 month project and get it down in about 8 weeks.
So it goes right on the front of the grill here during sub-assembly. They're doing about 50 per week. Savings was not just with time, it was with money, because obviously we didn't have to pay to update any injection molding tools. The beauty with the SAF technology on the H350 is we can nest a lot of these components in the same build. This one is directly off the machine, so this is our raw component, and then it goes to our supplier and gets painted to match the rest of the grill and all the other trim. This was our first production part.
So you see, things can be done. If it is a sort of short batch, definitely you can think about additive for using it. Now, apart from machines, the software also is very important that goes along with the machines. So the software that comes along with the machine is GrabCAD, where you can play a lot. It is designed to ensure that your parts are of good quality and of required strength. It can automatically have the strength wherever required. You don't have to define anything. So it will have the strength, or at the edges or at the corners, it will put more material to give you the strength. It has got an old embedded insert library, so you can just choose which inserts to be put and you can use this thing. So this software comes along with the machine. Okay. So additive manufacturing, if you are talking about prototyping, is there, but jigs and fixtures and production is something of an application. That is where additive will play a very important role. Okay. So I'm just going to go through it. As I said in my earlier, that medical I was not going to cover, but I came to know that we have certain people from medical industry, and this is one of the smallest case study, video case study which we did. It is just to give you an idea how additive is playing its role in helping medical fraternities.
My patient was a 23-year-old young man. His parents told me that he had been blue. So his nails were blue, his lips were blue from birth. And for some reason he had gone to doctors, but he had not been diagnosed. But then when he came to us, we investigated him. We found that he did not have any heart disease as such. So his heart was normal, which is very rare to have a normal heart and still be blue. To be blue, that means blood was going to the lungs, but instead of going into the lung, where it would have picked up oxygen, it was without picking up oxygen coming back to the heart, because there was this malformation, there was this mass where the blood was recirculating. That's called a arteriovenous malformation, a pulmonary arteriovenous malformation. Because of the CT scan, it looked like a very complex lesion. There were multiple branches of the artery, multiple branches of the veins, and then in between there was lung tissue which was being bypassed. And we could not, an X-ray and a CT scan is a two-dimensional picture. So then we got to know of Professor Rupinder, and we came to know that he was doing some work on a 3D printing. Now I'll show you the print. So this is the 3D print. And all these branches are exactly as they are in the body. So it is very precise, it is very accurate, and down to a fraction of a millimeter it is accurate. Now if we did not have this view or this knowledge of, here I can know exactly what is the length of this, what is the width of this. But in an actual patient, there is lung tissue on top of it. So to get to there, I will have to dissect blindly. Now because I know exactly how deep it is, I am not that blind. I am able to visualize in my brain, this lesion that I am going to is exactly 1.25 millimeters deep. So I will not damage any tissue. So in conventional surgery, I will be damaging more of normal tissue because I don't know what is lying where. So I'll have to dissect. So we would not have known exactly. I would have needed to go very, very slowly because I could not see through the blood, through the lung. But because I could see through, because I had this model in my hand, this was actually present in our operation theatre. So it just took us, I think, about 1.5 hours. Something which would have taken 4 hours. Now second thing is that because again we had an absolute knowledge of where the artery is, the blood loss was next to nil, maybe about 100 ml. While otherwise blood loss would have been much more, we would have needed maybe 2 units of blood. In this patient, we needed no blood. Now the patient had seen this lesion, so in his mind also he was clear what surgery is being done, and he knew both the advantages of surgery and also the risk involved. So it's both his parents also. And the moment we clamped this, his oxygen came back above 100 immediately without doing anything else. So this was a great boon to us, and the patient then recovered. He was wide awake after the surgery was finished, and within 2 days we were able to send him home. And his nails, you will see, are absolutely pink now. They were very blue.
So it's a great help for the society and moreover the medical fraternity with respect to the 3D.
So that was something which is used by the medical fraternity. It's one of the cases. So we have got huge cases where people have used our technology to save lives. Whenever I go to a medical college and I present something, it's like 2-hour session wherein we can talk about multiple materials, bone matrix, tissue matrix, gel matrix, different materials for different things. So that was what I just wanted to showcase to you. And thank you very much.
Thank you, sir. Thank you very much. We would like to felicitate you. I request Dr. Achyut Trivedi to please felicitate, sir. Please give a big round of applause. Thank you very much. Moving ahead, we are starting our panel discussion 2. The theme for panel discussion 2 is building a skilled and sustainable AM ecosystem. The panel discussion will be moderated by Dr. Satyen Parikh, Pro Vice Chancellor, Ganpat University, and Dr. Kishore Barat, Senior Director, Placement and Executive Education, Ganpat University. I request both the moderators to please come forward.
Till afternoon. It's a beautiful weather outside and beautiful event as well. The first panel discussion was talking about the industry applications, and normally what we have been witnessing, every technology that has come for the industry and industry use, the technology itself has its own life cycle. So 3D additive, probably it may be in the early phase of its growth or maturity in US or maybe in China. In India, the technology is of the recent introduction, and it's in a very infant phase, but I'm very sure that a lot of technologies that have been brought here over the years, the business, the small, micro, large enterprises, very nicely adopted, not only adopted, they have customized. And they have customized the technology in the Indian way, and which is scalable also. However, the early phase of any technology demands lot of knowledge transformation. And basically, I being a person who takes care of placements of the students there back of the auditorium, it is time. See, industries demand not only pure and plain mechanical engineer, but an additional certification in 3D additive. And basically this 3D additive center here at Ganpat University we as an academic university, our role is to spread the skilling part of this novel technology. And therefore, the second panel discussion, we're going to engage and we're going to ask some relevant question as to how do we skill and upskill our workforce. It's not only for students, basically even the professionals. Days are gone when you used to feel, I have done my mechanical engineering and now it is sufficient and I have relevant experience and therefore I need not to learn. Today morning, Sudep Gupta ji had told that students are students, the students are students in the campus and we are the students outside the campus. And therefore continuous learning is the need of an hour. Industries may not simply feel that we have already hired a talent pool and therefore subsequent learning, upskilling them, reskilling them. In fact, I'll share a very important incident here. Tata Motors and Ganpat University. Tata Motors is upskilling. We have a 9 years contract with Tata Motors, upskilling their ITIs to diplomas and diplomas to BTech. And almost every year, maybe a couple of hundreds of employees of Tata Motors, and a very unique model that has been curated between Ganpat University and Tata Motors. So with this, we're going to ask certain important questions as to how do we skill and upskill our workforce, and then it talks about, the panel also is going to talk about how can automation and digital integration can be harnessed, and simultaneously we are also talking about sustainability, right, and green manufacturing. That's again a need of an hour. It's not only about making something, it's also about controlling our carbon credits, and we're trying to be earth friendly, we're going to be environmental friendly, etc., etc. So with this, in fact, if you see at Ganpat University, we strongly believe that the future of advanced manufacturing depends on holistic ecosystem. It's not going to be into fragmentations and different players and components of this entire additive manufacturing walk into silos, right? So academicians, students, industries, all will have to come in a tandem supporting, and this is the, as I've been telling, this is the early part of the technological entrance in our country basically, and maybe we are very soon and going to fast adopt it, provided we all put our minds and hands and arms together, and therefore one that balance cutting edge technology with sustainable practices, industry needs with academic excellence and innovation with responsibility. So I think I'm confident that today's dialogue will generate ideas, strategies, and collaborations that can help collectively chart the roadmap for skilling, because early part of the technology, lot of knowledge, and this is not just by doing you will learn. You will have to, because there is a methodology, there is some concept. So unless and until as an employee, as a student, you don't understand this, and then you will need to put on hands-on. So it goes hands in hand. So they can easily collocate. You will have to do, you will have to take up a certification, you will have to register yourself with Dr. Achut's 3D additive, right? You will have to learn from all this. So I'm confident that today's dialogue will generate ideas, strategies, and collaborations that can help collectively chart a road for skilled, automated, and sustainable future in additive manufacturing. So with that, once again, I extend a warm welcome to all our panelists and participants. I look forward to an engaging and thought-provoking discussions. Thank you. And with this, I request my colleague, Dr. Satyan Parikh, to invite, introduce, and facilitate the felicitations of the second panel expert. Satyan, sir.
Thank you, sir. So in the second panel, building a skilled and sustainable additive manufacturing ecosystem, we have very good blend of people from research institutions, research industries, industries, sector skill council, manufacturing industries, machine manufacturing industries. So let me invite people one by one. So I am honored to welcome and introduce Dr. Sankhadip Das. Sir serves as a scientist E at the Ministry of Electronics and Information Technology, METI, Government of India, where he drives R&D, evaluation, policy initiative to advance India's technological ecosystem. In his role, he expertly guides techno-commercial roadmaps and contribute to shaping the national policies for the digital innovation. Dr. Das plays a pivot role in high-impact project and shares insight on additive manufacturing strategies, aligning with the national strategies for additive manufacturing and United Nations Sustainable Development Goals at the Technology Advisory Group of the Empowered Council. May I request Professor J.K. Prajapati to welcome Dr. Sankhadip Das, sir. Dr. J.K. Prajapati, sir, please. Thank you, Dr. Das. Now, I am privileged to welcome and introduce Shri Brijesh Kumar Poddar, sir. Shri Brijesh Kumar, sir, is a seasoned professional and currently serves as a CEO of the Instrumentation, Automation, Surveillance and Communication IASC Sector Skill Council, an automation organization under the Ministry of Skill Development and Entrepreneurship, Government of India. Sir, please. May I request Professor Viral Chauhan to welcome Shri Brijesh Poddar, sir, and felicitate him with the GUNI stall and memento. Thank you, Poddar Sahab. Please take a seat. Next, I am fortunate to welcome and introduce Shri Jasprit Sindhu. Jasprit Sidhu, sir. Sir is recognized leader in additive manufacturing industry, carrying an eagle eye view while driving implementation on ground. Currently, at the helm of affair of National Center of Additive Manufacturing as a CEO, keen to drive a broader engagement with the brands, business, startups, academics, and the research institute to implement additive manufacturing roadmap of India. May I request Shri Dhaval Soni to welcome sir and felicitate him with the GUNI stall and memento. Dr. Dhaval Soni. Thank you, Jasprit sir. Please take a seat. Now I would like to invite and welcome Shri Aditya Chandravarkar. Sir is an entrepreneur and MD of AM Chronicle and has device business interest spanning emerging technologies, deep tech, additive manufacturing, advanced material, composite, and many more. Since 2010, he has been deeply immersed in the ecosystem building activity for the various technologies like inkjet printing, additive manufacturing, 3D printing, 3D printing composites across India, Asia, and Middle East. May I request Professor Vipul P. Patil to welcome sir and felicitate him with the GUNI stall and memento. Professor V.P. Patel. Thank you, Aditya sir. Next, I would like to welcome and introduce Shri Rahul Pandita sir, who is Regional Head, Stratasys India, with 18 years of deep experience in the technology. He led Stratasys India commercial team to drive sustainable growth of 3D printing business in the region. Prior to this, Shri Rahul ji was the country manager at CATFAM India, heading their simulation business unit and managing growth strategy across the different industry segment. May I request Dr. Bhavesh P. Patel to welcome Shri Rahul Pradhan sir, Pandita sir. Bhavesh P. Patel sir, please. Thank you, Rahul sir. Now, I would like to welcome and introduce Dr. Madhu Vadali. Dr. Madhu Vadali is a learned academician in the Department of Mechanical Engineering at IIT Gandhinagar. Dr. Vadali earned his BE from Osmania University in 2008.
Students, may I request you to please take your seats back. There is one more panel discussion. Students,
please take your seats.
Yeah.
Panel discussion is going to start soon. So Dr. Vadali earned BE from Osmania University in 2008, followed by MS and PhD from the University of Wisconsin Madison. Prior to academia, he has contributed advanced research projects as a principal and senior R&D engineer at Halliburton Global R&D. Dr. Vadali's research span soft robotics, multi-robotic system, control system, dynamic system, and laser-based manufacturing. May I request Professor P.S. Chaudhary to welcome Dr. Madhu Vadali. Thank you.
The mesh will remain open till 2 p.m. So students are requested to please be over here.
Yeah, so on having the experts on the dais, again, I would just like to inform everyone that this 3D National Additive Center of Ganpat University, over and above Dr. Achyut and his team imparting consultancy to industries, they are also involved in 2 certifications, especially for professionals, and these are on physical mode, on online mode, for students also additional upgradation and upskilling of their existing degrees. Over and above that, additive manufacturing is not only about making products, it's all about people, process, purpose, etc. So to truly unlock the potential, we must focus on skilling the workforce. Industry applies a lot of obsolescences in skills, lot of redundancy has already been there, and especially when we have to adopt new technologies, I think the only way out to effectively adopt is to learn and relearn, right? So with this, let me invite our esteemed panelists to share their insights and perspectives on shaping a skilled and sustainable additive manufacturing ecosystem. And I will go to Sandhu Saab first. For Sandhu Saab, Jasprit Saab, what initiatives is NCAAM driving to ensure that AM's adoption in India remains sustainable, digitally intelligent, and globally competitive, especially for MSEMEs and public sector applications?
Firstly, thanks for inviting me. Little bit of nostalgic moment. I came here during December 2022, and that point of time the building was under construction, what we call it as the National Center now. So I was the first person to be mandated by MIT to visit here and understand if we can enroll them as a center. So now 2.5 years down the line, very glad that the center is up and running, industries have partnered, and we all gathered here to discuss and explore how we can take this journey forward. And I'm sorry to say that I have a hard stop in the next 10-15 minutes. I have a flight to catch at 4, so I'll be running in between. Please don't take it otherwise. So coming back to the sustainability of the AM ecosystem in India. So when I took over as the CEO of NCAM, so first, of course, I had to go through the national strategy which was released by Government of India. So there was many pain points addressed over there. And parallelly from NCAM, as an initiative, we decided to understand the ecosystem ourselves. So our entire team of experts which we have at NCAM, we started drawing up the entire ecosystem. So we took government data, private data. We completely understood that which companies are active in India at the moment and what exactly they are doing. And parallelly, which are the international companies active versus what are the domestic companies active in the country. So by doing this exercise, what we got was the problem statement. So we understand that what business case will make sense, what doesn't make sense. So after doing this exercise, we implemented that into our day-to-day journey, wherein one of the examples, when we are going for our startup incubation, as one of the mandates under the national strategies to have 100 startups to be incubated in 5 years. So when we go for a startup incubation, typically we get 40 to 50 applications. But the final selection is limited to 6 or 7. So whatever fits into our analysis, that what exactly is the shortfall in our ecosystem, and this particular startup is trying to fill that gap, so we select that particular startup, and then we ensure that the startup is successful. So this kind of exercise, starting from analysis to final implementation on the ground, ensures that whatever work we are doing is sustainable. Parallelly also, as Dr. Vishwas mentioned, we recently bought the metal machine, and we have a couple of other equipments on board. So for strategic applications, for defense, for aerospace, for private customers, we're trying to understand where is the gap which private sector can't fulfill. Maybe it's some kind of a new material development, or it's some kind of a design challenge, or it could be anything else. So we take up such kind of a challenges at NCAM, and NCAM is a R&D institute. We're not a production company. So we do the POC at our end, and then subsequently offload that POC to the industry for final commercialization. So with these kind of initiatives, we ensuring that the system remains sustainable, and whatever work we do is actually meaningful for the larger interest of the audience.
Thank you, sir.
Thank you. My next question is from Shri Brijesh Kumar Poddar sir. Sir, what is instrumentation, automation, surveillance, communications sector skill council, and how it roadmaps for building the NSQF, National Skill Qualification Framework, aligned skill qualifications specific to additive manufacturing? Are we seeing additive manufacturing roles being mainstreamed in ITI and other skill institute yet? Sir.
Okay, thank you. First of all, thank you for having me here. Before I start, I remember morning, Dr. Mahendra's one line, he said, your skilling, that is a kind of a revolution. We have to take a skilling in this country as a revolution, then only we can actually contribute to the making new India. So he said very important statement, the student has to be center of this complete revolution. तो फिर स्टूडेंट की तरफ से मुझे पूरी आवाज आनी चाहिए. Students, you are there? Good. Good. So, देखिए जहाँ तक स्किलिंग की बात है, if I say we as a sector skill council, I'll briefly tell you what we do. We as government constituted different sector skill council for different sectors. Now, our sector skill council is instrumentation, automation, surveillance, and communication. So this sector, the mandate from the government to the council is to work with the industry and identify what kind of skills are required by the industry currently or futuristic, and accordingly design the skill programs in consultation with subject matter experts from that domain. And those programs are again presented to the government, and there is a committee, there is a body, NCVT, they go through it, and once they approve that program, that becomes a national program kind of thing, and that is ready for adoption by the institution, different academic institutions. So we work closely with the industry, OEMs, and the end users. We work with the government, we work with the academic institutions, and the major stakeholders are students. So students, उन्हीं के लिए हम ये सारा चीज़ कर रहे हैं कि they are the future. Now before I say what we have done till now for this domain, additive manufacturing. So one thing, we can come up with different courses, but then one challenge I must address here, because here the industry is also there, a student is also there, academia is also here. Now, we all are the stakeholders. We are the links of the value chain, the knowledge delivery value chain. If you look at the knowledge delivery value chain from the knowledge generator to the knowledge receiver. Now, each link, if you look, the contribution from each link is very important. The contribution from industry, contribution from the government, contribution from academia. Now we all keep talking about there is a gap, there is a gap. We all understand there is a gap. No, it's not that today we are discussing this. Since last 15 years I have been discussing there is a gap between what we are teaching and what the industry needs. But today if I say okay, we have developed certain courses, skill programs for these students. Now these students, if we impart this kind of training to these students, are the industries are coming forward for some kind of OJT program? Are the industries they are coming, they are inviting students? Are they setting some kind of lab, learning zone in their premises? Your students can come and learn and can have practical experience. Now theoretically, again, when we say about delivering skills, it's about the practical delivery of skills. So they are employable, they can contribute. Now, unless until industry, despite the talk, if they come, unless until they come forward and they can really contribute towards the scaling, the progress will be limited progress. It will be conservative progress, like, you know. We also need support from the industry, because we work with the industry to identify what kind of skills are required. So we need subject matter experts from the industry. We need industry contribution, how they can contribute in designing some small modules, training modules, which can be designed and which can be given to the students across India. So this kind of participation at ground level is very, very important. Now coming to what we have done till now. We have designed certain skills program, okay, and one is at technician level, additive manufacturing technician level program. That is already approved by the government, and it is being adopted by many, has already been adopted by many institutions, and this kind of program is already in place, running in many ITIs also. That partially answers your another part of the question. Okay. Another is, we have recently designed small modules, micro credentials for 30 hours to give them exposure on digital manufacturing, focus on this prototyping, reverse engineering and modeling. Okay, so that we have designed. Then fundamentals of metal 3D printing. That also already being approved by NCVT. That is ready for adoption by the institutions. That some centers are already, they have adopted, they have trying to include in their regular curriculum. That will be offered to the students. Okay. Besides this, we are also looking at what is the future, how this technology is going forward, what kind of need from the industry will be having, so that we can create that kind of program. Some of the programs, like, you know, what, day before yesterday, I was reading one article, like, you know, hydrogen infusion additive manufacturing. Now this, I just gone through the article. Here, you can produce the alloy material, like, you know, the hydrogen is the scaffolding hydrogen is being, like, you know, infusion in some components, like, you know, you can produce alloy material. So these are the technologies happening, advancement happening. So we have to, we'll be trying to, this forum has given me opportunity to know many industry in this domain. So we'll be interacting with them. We will try to gain some insights, what we can actually do, how we can develop new programs which is going to contribute and advancing the advanced manufacturing ecosystem in India. As far as the ITIs are concerned, yes, our conventional ITIs technician level course, many of the ITIs, these programs has been adopted parallelly along with their current curriculum. Interested candidates, they are taking up this program, and we are the certifying body, so we are doing the assessment and certification also. So we'll be also looking forward, like, you know, how we can take up this program at Ganpat University. Thank you.
Thank you, Brajesh sir. You rightly said that there is lots of gap between the industry and academia, and through your council, you are bridging this gap. You are, it means bridging the gap between the industry and academia and the students. You will get the right kind of education for the cutting edge technologies. Maybe it is metal printing, maybe it is lots of other technologies, as sir has mentioned. So we have signed MOU today with the IASC Sector Skill Council, and the courses of IASC Sector Skill Council we will offer through our center. So you please take the advantage of this, it means courses, and you can develop the skill in these areas. Thank you.
If we look at the manufacturing technology in the broader industry perspective of India, you talk of a technology, may it be cement, may it be sugar, may it be anything, may it be petrochemicals. Most of these technologies were imported, right? This 3D additive itself may be a technology, may be invented by US somewhere, they may be patented, etc., etc. If you see today, most of the technologies, manufacturing technologies, are manufactured right here in our country itself. And a lot of innovations, a lot of customization, which has also enabled a lot of affordability and accessibility to small, medium, micro enterprises, etc., etc. And Dr. Das basically is an expert into this direction, and in line with that, there is a whole set of organizations set by Ministry of Electronics. Das Saab belongs to MIT, and in line with that, top priorities in coming years to deepen indigenous, basically, as I have always been of a view that adoption and customization. So deepen indigenous innovation infrastructure and startup enabler here. So what are the views and what is the direction that you have for the 3D technology as a whole?
Yeah, thank you. So let me introduce myself in a way that people will try to understand what I'm saying. So I am scientist by profession, so my understanding towards additive manufacturing comes from the fact that what are my advantages, technically speaking, engineerily speaking. And when you take that to commercial level, economic benefits, business benefits, how to introduce this technology in this country and benefit this country's economy. That is the perspective government is looking at, and that is the perspective I am also looking at. So in terms of skilling, as the session is a skilling structure, you have to understand what you are being skilled for. If you look at that point, then you will understand whether it is interesting to you or not. So if you want to make rockets, if you want to make robots, if you want to make drones, you will find that there are a number of parts. All of you, I think I've heard that 2 nanometer lithography machine has been made by ASML, which has been controlled by USA and not given to China. That machine has 100,000 parts. Who is designing them and how it is being built is very interesting. If you want to reduce the number of parts from those 100,000 to maybe 10,000, maybe 100 parts into one part, then you start using additive manufacturing. When you do that, you get something which is cheap, which means it's cost effective, which means you can have your salary up because your production cost has gone down. So you are making a robot, in jet engine or a LCA or a boat or a ship, whatever you are making, whether it is automotive, anything that you want to make, you have to make it using additive manufacturing in order to gain some very, very good design advantages. There are other advantages as well, but what it will do is essentially push your salary up because production cost goes down. Now, if you are looking at that from the interest of this kind of skilling, you are looking at how to reduce number of parts. That is the range that you need to have. Okay, so that is the skilling part that you are learning. So in order to push this technology, Government of India started with a national strategy in 2022. Under that strategy, we have established 7 centers. This center, NIMC West, is also one of them. What we are doing in the center is we have provided with the infrastructure, and this center is creating courses and syllabuses at all the levels, from ITI level, BTech, MTech, smaller 3 months courses, I think weekly courses as well, so that when you enter one, you understand what it is and you can go deep inside and do a PhD on it or a MBA on it. So that is this center is doing. This is where your interest comes in, Because if you are skilled with one such advanced technology, these are called emerging technologies, also it is called Industry 4.0 or 5.0. These technologies are going to be the backbone of India's future in next coming 2 decades. So you want to, in your entire professional career, if you want to grow, you will have to grow with a advanced technology so that you can get a advanced job which pays you more. That's why you want to do it. And if you are interested in advanced sectors that I have mentioned, then this technology is the one. Now, what this technology enables is additive manufacturing is the interface between material and electronics domain. So you are controlling the entire structure of production with electronics. When you do that, it's called a advanced manufacturing paradigm. Additive manufacturing comes first, which introduces artificial intelligence, which introduces AR, VR, and so on. Each of these have a functionality in manufacturing. Some accelerates, some gives collaboration, some allows distributed manufacturing, some allows sustainability, and so on. So it is if you learn this technology, you will learn a plethora of things that can give you skills to find a job or create a business for yourself. This is the purpose of this center, and that is, I am very happy to say I have seen tremendous growth in the center in last 3 years. From the conceptualization to the expansion mode that this center has come up with is a very, very commendable. Okay, so I think you guys need to focus on this center, learn the basic skills, and grow with it. And the industry that is coming in right now will help you to secure more better jobs at your end.
Thank you, sir. Thank you for sharing your views. My next question is from Shri Aditya Chandavarkar. Sir, in the morning inauguration session, Nagarajan Saab told about the chicken egg problem. My question is very much relevant with that, because you are working in a cutting edge technology as a managing director, AM Chronicle. So, sir, what are top 3 capability gap in India? India's additive manufacturing talent pool today, and how can we bridge this gap quickly? How can we create a seamless collaboration environment where knowledge and skill development in additive manufacturing co-owned by academia and industry? Sir, over to you.
Thank you. First of all, thanks for inviting me for this forum, and great to be here at this event. I think what I'm going to say is going to resonate with what everyone said today since the inauguration, what Shri Brijesh Kumar ji also said some time back. And of course, what my good friend Amir bin Ahmed from Abu Dhabi also said on quality assurance. I think there are 3 key areas, as you mentioned. I would say one is application-specific training, I think, which Brijesh ji also looked upon. What we are seeing still today is additive manufacturing is seen as a standalone tool and not a production technology. So the skilling or the courses we create need to bring in the DFAM angle, which is design for additive, because unless you design for additive, we are not going to convert more parts into additive. We are looking at the material knowledge, right? So today, when you're looking at conventional and additive, the company needs to have the confidence that this material will work in that situation. So material properties versus performance. I think this is anything which will drive more adoption. This third thing is looking at the viability, looking at the business models. I think this is also very important. The second point would be something awareness on quality assurance, awareness on standards, awareness on these aspects. I think that is also very important, because when you're looking at building confidence in larger organizations to use this technology, I think that plays a big role, standard certification, quality assurance. And I think the answers to this, I think some of our panelists have already given them, like micro-credential based courses, which
allow people to do specific training, where they are upskilling them in specific need-based courses. The industry participation in this exercise, right? So the industry needs to set their goals on what they want from the skilled workforce. I think they need to be hand-holding along with the academic institutions to take this forward. Again, I think couple of examples seen today at not AM, but Maruti Suzuki collaborating with Ganpat University and other aspects, and what again Brajesh Kumar ji said on the kind of courses we are building. I think that sums it up. But I think an important caveat here is we need to drive adoption, because unless there is a demand for these skilled workforce, this is not going to take off like all of us are envisaging. So I think that also needs to go hand in hand with this. The demand creation for additive manufacturing, which centers like NCAM are doing, or what METI has envisaged with the 7 centers. I think that needs to go hand in hand with this skilling initiative. Because if people know there are jobs, they will automatically go into that training. So I think it's going to then, that chicken and egg problem comes again, because if you have demand, then supply should not be short. So I'd like to conclude with that. So thanks a lot.
Thank you, Aditya sir. So we have National Center for Additive Manufacturing Waste, and
I would want to respond. So the good part about those 7 centers is they are simultaneously looking at creation of skill development and technology. So both parts are part of the program. So those 7 centers, some have formal skilling, some have informal skilling built into this.
Thank you. So sir rightly said that because of this kind of conclave brings the industry, academia, and other people, government agencies all together. So industry will adopt the technology, education. We can adopt if we can reframe the education, we can bring the new changes in the education, so it can be compatible with the latest technology, and that's how actually it means we have to solve this problem. Thank you, sir.
If we look at the education model of US or Germany or all developed countries, the academia and industry works very close in hand to hand. If you refer international, this global IPR report, you will figure out that along with the lot of innovations that have been going in Google are made in some university. And this is in synchronization with the professors of that university or that department along with the working professionals of Google, right, that practitioners. I think it is time wherein the pace at which we are witnessing the technological disruptions. By the time the industry starts addressing a solution, and after you have addressed the solution, it comes to the knowledge of the academia, and then a group of researchers starts researching out as to what was the problem and how they have addressed, and then the board of studies puts it into the syllabus, curriculum, and by the time there is a new problem, the old one is obsolete. I mean, that's what is exactly happening with India, our higher education, particularly the professional and higher education. And therefore, when all industries are here together in this 3D, and there are a lot of entrepreneurs and senior officers of CEOs from their respective units, I think let's not do that with this 3D additive, right? With this, again, when we're talking about skilling, I'll go to Rahul Pandita Sahab, which talks about how effective we are talking about micro credentials, very specific, job role specific skilling that is going to be there. So how effective do you find micro credentials or stakeable certifications in AM, right? And are there and what is the future of tech education?
Yeah. Thanks first of all for having me here today. I will answer, the answer to the question is extremely simple. The answer is yes. But I'll probably give you a small example. So let's assume a company like a Maruti, Hero, or a Striker wants to hire for their additive manufacturing or proto shop, as they call it on the manufacturing floor. They want to hire 20 engineers, from obviously engineering colleges. So there are probably lakhs of engineers, and they have to choose from that. So already the filtration happens when you have a good certification, and I think it's not as simple as that. I think sir said that there are 7 centers already, and they're doing very, very well. But I think for a country which is as big as India, I think the scale has to be massive. I mean, massive means we probably need, thousands and thousands, maybe a lakh or 100,000 kind of numbers, where we are able to skill them. So personally, as a professional who's working in this industry for a few years now, I see that there is a lot of gap. I mean, I think sir spoke about gap we have seen for a while, but I think the gap is not just in terms of the skill, also it is the adoption. Industries, adopting, additive in India is much lesser than to our peers in the US or Europe for that matter. They depend on technology because, you get less errors, and you save a lot of time and money. So I think those are some of the principles that we still need, inculcated, I would say, in our, how we work. And obviously, at the end of it, it has to be between the industry, the academia, and the government. Because I can, I commend Ganpat University. We have been associated for a few years now. And it is, I think, Dada said in the morning, he was a little ahead of the curve. But that's exactly what we are talking about, the vision of, thinking already that this is going to come up big time, and we should really start giving our students and, working with the industry and the government also, thanks to Dr. Das as well, that they have, really started working with Ganpat University. And I think we need a lot more of these, institutes to really come up and look for the future, and the future of, all of the kids, also the industry. I mean, today, if, some of these companies, they're actually already running, behind their schedules. Everybody is so pressed for time, and, there's so much pressure in the, in the real world out there, in the product manufacturing segment, like cars, aerospace, healthcare products, companies, that they don't have the time to, I will not say waste, but they don't have the time to really start skilling people. They want graduates who are ready to go from day one. Okay, so of course I'm not putting so much pressure on the kids, but this is exactly the need of the hour. From our side as industry and from the government side, I think we need more help from you, and of course we need better skilling at all levels, and of course certification comes. And also another point that I'd like to make is that it also depends on the quality of certification. Okay, I mean, we have seen, some of the OEMs not accepting, let's say low-cost additive manufacturing machines being used in some institutes. The OEMs don't accept that because they say that, okay, we are using, quality technologies, and your certification should be on, technologies like that. In healthcare, you have to really getting a machine doesn't solve any problem. You have to really be able to read the DICOM data to be able to print in a 3D printer, which obviously is a lot of work. So right certification with the right, content of the certification is also extremely important. Thank you.
Thank you, Badhuji. Thank you, Rahulji. Thank you for sharing the details. My next question is from Dr. Madhu Vadali. Sir, you are from IIT, and IIT is known for its proactive initiatives in education and research. So this is the emerging technology. Since morning we are talking about the additive manufacturing. So I want to understand that how are, it means IITs are integrating the additive manufacturing in the engineering curriculum and research agenda across the discipline. And also, it means we have talked about the deform design for additive manufacturing. So this kind of initiative, how you are integrating in curriculum of IIT?
Thank you. Thanks for having me. I see a lot of people are hungry, so I'll keep it short. To begin with, I strongly believe that today we need problem solvers who are skilled at engineering to address industrial and societal problems than just engineers. These problems and engineering solutions have transcended across discipline and do not fit into traditional silos anymore. And we saw an opportunity through additive manufacturing along with other digital prototyping tools, you know, whether it is laser cutting and other desktop machines, that we can enable our students to become problem solvers. How do we do that? In their first year, they do not learn what is additive manufacturing, but they use desktop 3D printers right off the bat. They identify problems. They come up with solutions. They try to prototype their solution. They fail, which is excellent because that is a big learning for them. And they iterate. And that is what these digital prototyping tools have created, including additive manufacturing machines. Now, these are available today for 30,000 rupees on Amazon, right? I mean, that is what we use because it allows for this iterative learning and to really understand the core of the problems, right? So with these tools, we have created what we call as maker spaces. We are one of perhaps 10 or 12 institutes across the country that have adopted this idea of maker spaces, which have these prototyping schools, tools that are there. And we embed all traditional courses to be operated out of these maker spaces. There is always a component of making in whether you take a traditional heat and mass transfer course or a robotics course or a mechatronics course, it doesn't matter. And therefore, it is getting embedded as a tool for them to make things. Now, some of them who get excited naturally would want to understand what is the physics behind. And then they take up more advanced studies. But at the end of it, all of them know how to use it. And that is how we are sort of embedding these tools in our curriculum and pedagogy. Thank you.
Thank you. Thank you, Dr. Madhu. Now we have very good discussion, and I would like to open the forum for the questions, if you have any. We
can take 1 to 2 questions.
Yeah, 1 to 2 questions we can take from students, from the audience.
My question is for Das sir. Sir, there is a challenge for the manufacture of the composite materials. So is there any chance or the possibilities to manufacture the materials using the natural fibers?
I need some context to that. What kind of composite material and which sector you want?
For additive manufacturing, especially.
Oh,
can we use
additive manufacturing? I'm looking for which sector you are looking at.
For compatible material with the available materials, can we replace?
Let me take it as a general question. If I want to do a 3D printing of composite materials, the composite materials depending upon different sectors can be different, and composite material creation is just mixing basically. Okay, yeah. So if you are mixing ceramic with polymer, that also is a composite, and if you are mixing ceramic with ceramic, that also is a composite.
Just like a bagasse fiber,
so
or husk.
You are mixing bagasse fiber with polymer for making furnitures?
For medical applications or
bagasse is medically allowed?
I don't know exactly at presently, but that's
people make furnitures out of it.
Yeah.
So if you want to do that, you just need a mixing machine.
Right.
Batch mixing machine will do the job. You can do it right here.
Okay, but what about the compositions, or can we conduct the experimentations somewhere else, or
You want characterization?
Yeah, characterization.
Characterization, there are several institutes. I think some of it might be in IITs. Or if you want particular characterization, you can contact me. I can get you where those machines are for you. Mixing, I would suggest to you to do it on a small batch mixing machine. They are very cheap. If you don't do that, what will happen is you won't have the control of the percentages that you want.
Right.
So if you give it to somebody else to do that, you are not in control of your composition.
Because currently in our additive manufacturing, few students are working on that.
Yeah.
But
so
we are facing such kind of the problems. That's why I have asked.
So mixing is not a very difficult thing, or you know, they look like atta mixing machines. I'm telling you, they were deliberately atta mixing machines.
Right.
Those are batch mixing machines. It depends upon what kind of mixing you need and what kind of kneading you need.
Okay.
Okay, so if you have a shear stress, you can go for single screw, double screw, or batch mixing for slurry. It depends, really depends upon what is your mixing requirements, what is your viscosity, and what is your shear requirement.
Okay, so we should know the
So it depends upon which, so composite materials can be utilized in space-based applications. For those, those are nanoparticles. So when you do that, you need to have a particular shear. If you don't do that, then your mixing is not homogeneous. So it depends, really depends upon what is the criteria of the material that you are going to produce.
Yes, sir.
Okay, so if you need help in that, I can suggest a few people who you can talk.
So thank you very much, sir, for giving answer. Thank you.
Hello, I have one question for the panel. Hello. Am I audible? Yeah. I have one question for the panel. I come from the industry, and we are actively looking for a lot of companies like mine are looking for low volume production ready additive manufacturing. So we are facing challenges in terms of materials that can be deployed in high temperature outdoor environments, as well as the cost per unit of production. For example, when we are dealing with ABS and we are dealing with HG, we are facing a lot of problems in terms of the materials ruggedness, materials reliability when it is deployed, let's say outdoors in 45 degrees, or let's say in high humidity. The material starts to warp, it starts to discolor. We also don't have a lot of post-processing techniques that will last in the outdoors. So for example, we have our electronics enclosures for weather stations. We have our die-cast parts that we are trying to now replace with additive 3D printed parts, basically FDM. Now, I would like to ask the panel of how the industry is going to address the fact that these materials are not ready for outdoor use. How can we get better materials at, let's say, very affordable costs for companies like us in low volume production?
Okay, so it's not a simple answer, but maybe it will help. So it depends firstly on the application of what you're using. In terms of materials, I mean, we are, as a company, I'm talking on behalf of strategists, so we are having parts on a flight. Okay, so which go through rigorous certifications. We are, this electronic box that you talk about, Intel is actually, making similar parts. That's just coming to my mind because, and the LGs and the Samsungs on the world are using it for similar applications. And I think for low cost volume, we really need to understand the size and what you want. I mean, I know for a fact that for a company in the US, we have printed huge numbers, 10,000 plus, in about a week for a coach. Okay, so I don't know, I can't share the name of the company, but it's an American company and they are based in Bangalore. So we did that for them, and even healthcare companies are doing this now. I think it's, I would suggest that maybe it's because of lack of awareness a little bit, and I think this is what we are trying to address here. But please get in touch, or maybe we can share you know, email addresses and see how we can work with you. Yeah, should be possible.
Yeah, so that's international company giving you a quality product that can match aerospace and defense qualities. If you are looking, 3D printed can be used for making this bottle as well. That does not require that kind of precision. So it really depends upon what you are trying to make, one. Second is, additive manufacturing business has a different business structures. So if you are looking at you starting small, you will be looking at buying a one machine, adding, keep on adding, maybe 400, 500 machines you will grow into, and you can supply 100 or million parts in a year. So if you want to play the economy of scale game, additive manufacturing is not suitable, but it can compete in cost when your material is low and you have a design structure which is very suitable for lowering the cost. I mentioned that I will give one example. There were several examples here last time as well on the PPT. One antenna, it's a RF antenna to be fitted on satellites, is a 2-foot antenna. It requires about 12 months machining on CNC to get the surface finish for that quality. That antenna was 3D printed in, I think, 2.5 months with a design that reduced the size of the part approximately 80%, weight by 95%, and the cost by about 70%. So it depends upon that ingenuity of that designer to reduce the 100 parts into one. That reduces your cost. So innovation in design gives you the cost benefit when you can utilize, the system is able to utilize that innovation. CNC will not be able to do that, subtractive process. So it really, you want to reduce the cost, material is the first, second is the design, third is when you are doing it, what is the business model you have? Depending upon that, your cost will go down. Now, engineering problems, every manufacturer has engineering problems. Since this is not a fixed product, you get to have different products because of the servicing structure of the business. You will keep on having a lot of different issues when you manufacture. But those are solvable. Unsolvable, they are not unsolvable. Okay? If you try to make a machine part with a CNC one structure, you probably is not going to use that structure to make another product out of it. But additive manufacturing, you can do it. You can service the automotive sector in one day, next day your products can be servicing the space or defense or a bottle making company. So your number of problems may increase, but the solution lies in having a very good design engineer. That reduces your cost. I think that explains to you.
Thank you. I hope that you got the answer. Yeah, please.
Yeah, please.
Yeah, good afternoon, panel. I just wanted to, ask to the panel that being a small scale and a new startup for filament manufacturing, how can we have a collaboration with the government and have a good quality filaments materials that can be used for DRDO or maybe aerospace and healthcare industries?
That's up, please.
So congratulations on your opening up a startup.
Thank you so much.
Startup essentially means a new business. And you are using a new technology to produce something, either it is not existent or it is existent. So if it is not existent, then your market really drives your cost point. If it is existing market that you are looking at, then you will have a lot of competition. That drives your cost point, right? So if you are making filaments, the first thing that you need to do is whether you can use recycled materials. I will give you an example. Your HDP cost about 80 rupees per kg. If your HDP is a virgin, it will cost you 120 rupees per kg in West Bengal. In Gujarat, it will not cost you 120, but lower than that. If you have recycled, virgin recycled, then you will have around 60 rupees kg. But if it is not virgin, it will cost you about 50 rupees per kg. So it really depends upon where your application and how much recycled material you can put in. Raw material cost is one of the driving points. Second, your machinery is large. For filament making, you do not need huge size bath, water baths. You can have micro baths with the chilling control. Then your cost will reduce down because your investment cost will lower. Now comes the market. Market, I will suggest not to look at the defense and the government because their procurement rules are extraordinarily stringent. Your business will grow faster if you can build your customers in the industrial domain. Okay. They will provide you with larger volume and more often. Government does not give more often situation. Okay?
Thank you so much, sir.
I think now, please, we can now take more questions now. Yeah.
Hello. Yeah. Thank you very much. Now I would request Mr. Romil Patil to give concluding remarks on the panel discussion.
Good afternoon to everyone. As we wrap up this panel on building a skill and sustainable additive manufacturing ecosystem, some strong insight emerged. We heard that the future additive manufacturing education lies in micro-credential and stackable certifications, which keep professionals continuously relevant. But beyond training, India's additive manufacturing talent pool still has capability gap that demand close collaboration between the academia and industry. Only by co-owning the agenda of knowledge and skill can be created a workforce that is both agile and the future ready. Our panelists also highlight how policy and national mission are centralized. The Ministry of Electronics and Information Technology is steering indigenous innovative infrastructure and startup enablement, while NCAM is ensuring additive manufacturing adoption remaining sustainable, digitally intelligent and globally competitive. The sector skill counseling is working to formalize additive manufacturing role through NSQF aligned qualification, embedding them into the ITIs and the skilling institutions. And academia, as well as YERD, must embed sustainable and life cycling thinking into the design and the research, shaping engineers who design not just for performance but for the planet. In summary, building a skill and sustainable additive manufacturing ecosystem is not the responsible of one stakeholder, it is a shared mission. It requires industry, government, academia and the startup to move in step, ensuring that India not only build capacity but lead globally in responsible and inclusive additive manufacturing adoption. On behalf of all of us, I extremely my gratitude to our esteemed panelists for their valuable perspective and to the audience for the encouragement. Together, let us continue shaping an additive manufacturing ecosystem that is skill, sustainable, and future ready. Thank you very much.
Thank you. With this, we formally conclude the panel discussion too. For the vote of thanks, I would request Dr. V.M. Patil to please come forward.
Very good afternoon, one and all. Respected dignitaries on the dais and off the dais, esteemed guests, and my dear students and faculty members. It is indeed my proud privilege and honor to propose the vote of thanks on behalf of the whole Ganpat University Parivar and the organizing team of National Additive Manufacturing Conclave 2025. At the very outset of this event, we are deeply honored by the words of blessings and wisdom shared by the Patron-in-Chief and President of Ganpat University, Padma Shri Ganpat Bhai Patil, our beloved Dada. Dada, your vision and continuous guide us towards the building a society where education is not just a privilege, but the one powerful tool for the change. Dada, your enthusiasm and energy light the way for all of us. Our sincere thanks to Honorable Group Pro-Chancellor, Dr. Mahendra Sharma, who always inspires us by providing his constant guidance. Your steadfast belief in empowering the youth has made this university a hub of creativity and excellence. Your vision has always guided the university to take the pioneer steps, and today's conclave is another milestone in that journey. I extend my heartfelt thanks to Chief Guest, Shri M. Nagarajan, IAS Vice Chairman and Managing Director of Gujarat State Road Transport Corporation, for gracing us with valuable presence and sharing the insightful words. My special thanks also goes to our distinguished guest of honor and inaugural dignitaries, Shri Sudep Gupta ji, former Executive Director ONGC, Shri B.H. Talati sir, Commissioner and Director Technical Education, Government of Gujarat, Dr. Sankhadip Das sir, Scientist E. Mighty, Government of India, Shri Ajit Shah sir, President Sanand Industrial Association, Shri Brajesh Kumar sir, CEO IAS SE Sector Skill Council. Your words have added immense value to this event and given us the rich takeaways. I would like to thank all the members of Board of Governors, Trust Mandals, and their constant support for guidance. We are very much thankful to the sparing your valuable time to bless this event. I'm also extend our gratitude to our distinguished keynote speakers, Mr. Amir bin Ahmed, Vice Chairman ASTM International, for his keynote address, and Shri Ravi Patil sir, General Manager Design Tech, for his insightful thought. Your visionary talks have not only enlightened us, but also set the tone for the meaningful deliberations. We are equally grateful to our eminent panelists of Session 1, Transforming Automotive, Healthcare, Aviation and Electronics Industries with AM, Shri Vinay Srivadas, General Manager Unimac, Dr. Girish Amlani, Senior Plastic Surgeon from Zydus Hospital, Shri Kupal Chudasma, Vice President Orthomax India, Mr. Rahul Gaywala, CEO STPL 3D, Mr. Vishwas Putige, CEO Amaze Solutions, and Mr. Franklin Detty, Business Head, Additive Manufacturing, Primer Solutions Private Limited. Thank you for your insightful case studies and thoughtfulness for the future of this particular field. Similarly, my heartfelt thanks to the distinguished panelists of the Session 2, which is building a skilled and sustainable AM ecosystem. Our panelists are Aditya Chandravakar, Managing Director, AM Chronic, Shri Brajesh Kumar, CEO ASC, Shri Rahul Pandita, Head of Commercial Business Strategies, Dr. Madhu Wadali, Associate Professor, IIT Gandhinagar, and Mr. Jatpreet Sindhu, CEO NCAM. Your valuable thoughts on workforce development, automation, sustainability, and green manufacturing have been thoughtful working and will surely contribute towards the shaping a strong national strategy for additive manufacturing. On behalf of the university, I also extend the gratitude to our Pro-Vice Chancellors, Dr. Rakesh Patel, Dr. Satyen Parikh, Dr. Saurabh Dave, Dr. Girish Patel, for their constant encouragement. I also take this opportunity to thank my organizing committee, Dr. K.P. Patel, Dr. Achyut Trivedi, Dr. Kiran Amin, and my dear faculty members, and my volunteers and students. Also, thankful to Mr. Vriel Chauhan for his contributions, and our anchors for today's event. We are equally grateful to our industry partners and sponsors. For our event, the sponsors are Stratasys, Design Tech, STPL 3D, 3D Selfie, S Micromatics, Go3D, Hexagon, and Kodiar Solutions. At the last but not least, I thank each and everyone who is contributing towards the success of this event, directly or indirectly. Thank you very much. Jai Hind.
Thank you very much, sir. I would request all panelists to come forward for a group photo, please. There are some instructions, please wait for a while. Thank you, sir. We will now move forward for a networking lunch. This is a great opportunity to engage, interact, and collaborate. After lunch, all delegates are requested to visit NAMCW, that is our National Additive Manufacturing Center West, where advanced infrastructure across domains of polymer, resin, FDM, 3D scanning, and material testing will be showcased. This will be followed by interaction with experts at the center. Thank you very much, one and all. Thank you, sir. Thank you.